And this is one of those stories that's once again going to be kind of rewriting textbooks. But not because something groundbreaking was discovered. Instead, this is something a little bit more intriguing and a little bit more fascinating. We're going to be talking about Neptune and Uranus, with a recent groundbreaking study definitively establishing that all this time we were kind of incorrect about the color of Neptune. But not because it was recently measured to be different, or because the telescopes got better and so we see more. Instead, this is actually a kind of a story of how, as humans, we process information over time and how we tell stories to each other, eventually influencing our understanding of everything around us, including facts and even scientific facts that can be misconstrued over time. And not because someone lied or because of some kind of a fake news phenomenon, instead a result of people not reading a side note and focusing on the visual presentation, taking it as a scientific fact. And so, hello wonderful person, this is Anton. Today we're going to be discussing this relatively recent study that once and for all determines that, yeah, Neptune is actually not the color we always thought it was. Here's actually one of the recent images released by Hubble from just a few months ago. And it does not really look like this at all, with all of the images presented in the last few decades sort of being really exaggerated and not really showing us the true colors. And really because it formed, I guess, a kind of a trend without anyone ever checking if this is really correct. And also because a lot of digital cameras used on a lot of different telescopes very often just send us digital data that then has to be reconstructed by scientists in order to make visual sense out of everything. And though for many planets like Jupiter, we basically know that it doesn't really look like this, and this is more of an artistic representation combining different frequencies including infrared into one. Or here's one with the ultraviolet light for comparison. With Neptune and Uranus, the story is entirely different. And here I actually wanted to start with one of the videos you can find in the description that talks about a relatively recent study from 2022 that tried to explain why Neptune and Uranus look so different despite extremely similar composition and even relatively similar distance from the Sun. And the focus here was on colors only. And just to summarize that video, essentially it was all because of the distribution of different hazes or different types of molecules such as, for example, ethane and ethine, and even things like methane, that seem to make Neptune just a little bit darker. And according to that study, Neptune basically just has an additional layer with a lot of methane condensation that makes it look different. And though by itself the study is definitely still correct and does present us with a really good explanation, what's intriguing here is that it was all based on misconceptions about the true colors of these planets. And so how exactly did all of this start? Well, it all started back in the 80s. NASA's Voyager 2 probe, that was launched back in 1977, collected a lot of imagery from all of the gas giants, and that of course included Neptune and Uranus. But the images for Neptune and Uranus were taken in two separate color bands. And when the probe sent back the data to planet Earth, the researchers processed them in slightly different ways. Here's, for example, raw data from the James Webb Space Telescope of Neptune in infrared light. And so these initial images looked somewhat similar. They didn't really have a lot of color in them. But when the images were released to the public, they were processed in a way to emphasize the colors for Neptune, and specifically by deepening its true colors, making it appear a lot more blue. And though Uranus was published in its true colors, the images for Neptune were a little bit more dramatized. They were enhanced to make them look slightly different. Now it's not entirely clear why this was done, but it was probably to present these two planets as basically different. They did look extremely similar initially. This is of course what these images looked like. And so a lot of this blue color in Neptune is technically artificial. But intriguingly, this was not a deception. As a matter of fact, there was a side note. A tiny caption explaining that the Neptune's colors were enhanced and did not represent reality. But who reads captions anyway, right? I mean, maybe you do, and maybe I do, but over time, this tiny side note has been completely lost, with Neptune becoming bluer and bluer over time. And here's how blue it looks in the Hubble images from 2021. Now once again, this is enhanced to make it look slightly more dramatic, but at this point the scientists working on this basically thought that this is indeed what it might look like, and they just had to bring up the colors to make it appear as Neptune should appear, making this an extremely interesting example of misinformation spreading over time and technically becoming scientific fact. As a matter of fact, I'm pretty sure in most textbooks that have Neptune in them, it's going to look just as blue. So if you're still at school, or if you have a child at school, I guess get one of those whiteouts and start spreading the colors, making it look as it really should look. It should be extremely similar to Uranus. And here's a fun fact. When I was making this video, I went on Wikipedia and guess what? All of the major images for Neptune have been correctly changed to represent the true color. It even says this in the captions. Even this iconic image that compares Neptune to planet Earth has been changed to reflect the reality. And this is indeed what Neptune looks like. Extremely similar to Uranus, actually let me show you the comparison, and practically indistinguishable from the other ice giants. In contrast, this is what it sort of looked like just a few months ago. So yeah, this is a huge difference. But all of this came as a result of a recent reconstruction of these original images by essentially using additional data from the Hubble Space Telescope and the data from the Very Large Telescope in order to reprocess images once again by focusing on true colors as opposed to enhancement. And so these new images show us Neptune as much lighter and definitely not blue, but still a tiny bit bluer than Uranus. Once again, you can sort of see this in this image. And that's of course related to that study from last year in regards to the methane condensation in the atmosphere of Neptune, or basically a tiny thin layer of various types of hazes in the atmosphere that shift the colors just a little bit. Although here these new observations also tell us a little bit more about Uranus and why this planet changes colors slightly over time, specifically over the period of its year which lasts for 84 Earth years. Because the planet orbits on its side, the effects from the sun tend to change the poles of this planet, making them appear slightly greener. But during different seasons, when different parts of the planet face the sun, they shift to appear a little bit bluer. And so basically the changes in color on Uranus, not on Neptune, are entirely due to its orientation as it orbits the solar system. So once again, this planet orbits on its side, and here is roughly how it changes over time as viewed from planet Earth. This shows us the change over a period of approximately 45 years. And the main explanation right now suggests that it's very likely because of methane once again. There's more methane on the equator than in the poles. And this changes the way Uranus reflects light. Since methane absorbs red light, it basically reflects green light, making Uranus appear a little bit greener at certain times. But this does not happen on Neptune, because Neptune does not spin on its side. And at the same time, there is something else Neptune has that Uranus doesn't: clouds and different types of storms. Now, interestingly, the clouds on Neptune seem to have disappeared for now, although it's currently unknown why, but it's most likely some kind of a seasonal change. But more importantly, Neptune's atmosphere has a lot of active storms. Here's an example of a very famous Great Dark Spot, something that seems to be dynamic and changes over time and sometimes disappears. Now, both Jupiter and Saturn also have different types of storms, but for some reason Uranus doesn't. And so despite similar colors, these are still very different planets. Neptune even has unusual hotspots in its atmosphere where the temperature can be up to 750 Kelvin. This cannot be coming from the sun, and so it has to have some kind of a different origin. Previous studies suggested that it's probably some kind of an aurora or some kind of a magnetic reconnection, but the real reasons are still unknown. Which means that there is still so much to learn about both of these planets, and someone should definitely consider launching a mission to either one of these planets or maybe even both planets at some point in the future. Here's another interesting image of Neptune in the infrared light, showing us the clouds as they change over time. This was actually taken just a few hours apart, and so the atmospheric activity here is quite extreme. And so in conclusion, all of this reinterpretation was because of this study. And all of these previous images that showed Neptune as much bluer, in essence were kind of incorrect. Here's one of the more extreme examples that really shows this planet as super blue, which it definitely is not. And so since we've been actually finding a lot of these Uranus and Neptune-like planets out there, in a lot of different star systems, understanding the true colors of these planets and what's happening in them is also important for a lot of exoplanetary studies as well. And so next time when we hear Neptune-like planet, we shouldn't really imagine this as much as this. So yeah, definitely important, and definitely a really interesting example of how a tiny side note can be lost in time and eventually lead to a complete misrepresentation of real scientific facts. And in this case, even a lot of NASA scientists seem to have forgotten about this. But luckily, after a few decades, Someone caught the mistake and now we have the true picture. And looks like it's that time of the year again. Time to once again talk about Oumuamua, the unusual cometary object that came from another star system, flew through the solar system extremely fast, and then surprisingly started to acquire unusual deceleration. And even though this is kind of common for comets, as in we usually see the cometary tail, which often changes the trajectory of the comet by just a little bit, in this case what was mysterious is that nothing was actually seen from Oumuamua. No cometary tail, no outgassing whatsoever, and this was even explored in infrared frequencies because maybe it was just different gas, for example some kind of a carbon compound, but nothing was detected. And as a result, as you probably remember, there was a proposition that maybe this was some kind of a extraterrestrial alien probe, specifically some kind of a sail that was basically tumbling around and was decelerating because the sun was pushing on the sail itself. But it didn't really take long for someone to propose a much better explanation that eventually pretty much most scientists accepted. It was very likely an ancient pristine comet, potentially pancake-shaped, and very likely contained a lot of hydrogen compounds because it never interacted with any star and was very likely formed on the outskirts of a star system. And as a result, these hydrogen and helium emissions resulted in the deceleration we see. Now that story you can learn more about in one of the videos in the description, but what's even more important, we actually finally have a proof of this from right here in the solar system. Or I guess let me rephrase this. Someone just found 6 of these that seem to be in orbit in the solar system and have always been here, we just didn't really know about them. And even more importantly, we're actually going to be visiting one of them in early 2030s. And so, hello wonderful person, this is Anton. Today we're going to discuss this super intriguing study that somehow I missed last year, that literally discusses the idea behind Oumuamua, potentially finally solves the mystery once and for all, and presents us with a new type of a comet. They actually refer to them as dark comets. Comets that have emissions that you just cannot see. Yeah, what is it with astronomers and their dark stuff? Dark matter, dark energy, dark comet? I'll never understand. And so anyway, let's discuss this in a little bit more detail, but I guess let's start with a bit more background here, especially when it comes to, I guess, defining comets, asteroids, and so on. Mostly because, unlike what you see, I guess, in textbooks, there isn't really a specific boundary between comets, asteroids, or a lot of other smaller rocks in the solar system. So for example, even though what you see right here is technically an asteroid, asteroid Bennu, NASA did actually discover that it seems to produce a tiny bit of deceleration as well from very small outgassing. So technically this is, I guess, what you would call an active asteroid. Here it seems to release approximately 1 gram of dust every 3 hours, mostly as a result of tiny outgassing, and though it does not produce a wide visible tail like around a typical comet, just the fact that it does outgas, by definition kind of makes it already intriguing and somewhat cometary. Although in this case it's unclear what's producing it. That mystery of Bennu has not been solved just yet. As a matter of fact, even Ceres, the largest asteroid, or technically a dwarf planet located in the asteroid belt, also produces a bit of outgassing as well. But for the most part, all active asteroids seem to be mostly so-called rubble piles, basically a collection of rocks that eventually assumed a single shape. The other famous example being the asteroid Ryugu. There are some additional discoveries from this asteroid that were made not so long ago, and you can learn more about this in the video in the description. And so because of this, it's kind of hard to define what a comet actually is. Is it just an icy object that produces a long tail, potentially formed on the outskirts of the solar system, or is it something entirely different? And in that case, what exactly is an asteroid? Now, by one definition, it's basically an object that seems to lack volatiles, or basically ices, mostly because it was exposed to the sun for a little bit too long. But this definition also suggests that maybe many of these asteroids used to be comets as well. So maybe this is some kind of a transition stage. And so in a nutshell, there's really no clear definition or accurate description for what comets are and for what asteroids are. As a matter of fact, quite a lot of objects on cometary orbits do not seem to even produce any tails whatsoever, even though technically they should. And vice versa. Some asteroids seem to produce tails, even though they shouldn't. But this is of course super important to understand, because recent studies also discovered that a lot of this dust and a lot of this gas from the cometary tails might actually be responsible for a lot of organic and even non-organic materials that eventually resulted in life on Earth. This is actually the discovery from Ryugu that was made not so long ago. Mostly because a lot of these particles seem to eventually end up on various asteroids that then collide with various planets, including Earth. But let's go back to Oumuamua. So here we had a comet, it was clearly showing deceleration, yet no tail whatsoever. This was observed in infrared light, this was observed by various telescopes, and no typical tail was detected from anywhere. But the deceleration was actually very similar to what a typical comet experiences when it does have surface outgassing. So in that case, what exactly was coming from the surface of this object? And though that answer was basically debated up until recently, now there seems to be a definitive explanation. It comes from a couple of papers by Daryl Seligman and David Farnosia that at first revealed unusual observations from another object known as 2003 RM. And so this paper, the asteroid that wanted to be a comet, talks about a very intriguing near-Earth asteroid whose orbits can be tracked extremely precisely because of its proximity to Earth. And over time, what the researchers discovered is that its unusual changes in orbits cannot be attributed to your typical effect from the Sun, from the solar radiation pressure. That's actually what most asteroids experience when they orbit the Sun. This is actually known as the Yarkovsky effect, and you can learn more about this in one of the videos in the description. But in a nutshell, as the Sun warms up one of the surfaces of the asteroid, and as the asteroid spins around, those warmer sides start to actually emit tiny amounts of photons, which kind of serve as extremely weak rocket engines. This animation from NASA sort of helps you visualize what's going on here. And so it wasn't this. It was not the effect from the Sun that creates these miniature emissions. It was something else. But once again, no matter what they tried to look for, there was no tail, no cometary emissions. And so the initial proposition was that, okay, maybe it's kind of similar to Oumuamua, some kind of an unseen cometary outgassing. And possibly outgassing caused by sublimation of water that would actually be somewhat difficult to detect using the telescopes used in the study, unless the outgassing was extreme or also involved some kind of a carbon compound. And then it didn't take long to find 5 more of these objects, all 5 basically being near-Earth asteroids, and all previously assumed to be inactive objects representing something similar to Ryugu or Bennu. But all 5 had this unusual acceleration that could only be the result of outgassing, or I guess they were all alien probes. But in this case, we do have images for some of them, and they do seem to be more or less spherical and asteroidy in the way they look. And one of the reasons these objects were assessed at first is because of their somewhat regular, non-peculiar orbits. And more importantly, they all seem to be relatively small and also have rapid rotation. And though it's obviously still unclear exactly what they are because they're so small, what this paper suggests is that these are essentially Oumuamua-likes. They're all very small objects, rotating very rapidly and emitting gas that's not seen very easily, which then changes their orbits just a little bit. And once again, Yarkovsky effect could not explain these observations. These effects were just too large to be produced by the Sun itself. And so if this is a result of water sublimating from the surface, but sublimating in very small amounts, it actually directly explains the observed orbital changes. Moreover, a lot of this outgassing potentially made these objects much smoother and removed a lot of surface dust usually found around bigger objects. So basically something that you see on the surface of Bennu. Here the outgassing is not strong enough to remove all of these surface features. And lastly, their fast rotation can also be explained as a result of this outgassing. So it's quite possible that Oumuamua and all of these other 6 objects are spinning really fast due to this outgassing or sublimation of water on the surface. But the overall outgassing is still really low, possibly something like 1 gram every 5 seconds maximum. And so this would be extremely difficult to see unless we came extremely close to one of these asteroids and potentially sampled them and took much clearer pictures through some kind of a flyby. But as I mentioned in the beginning, there is of course good news. These dark comets might officially be explained by early 2030s. And that's because one of these objects is going to receive a flyby from Hayabusa 2, mostly because their orbits are somewhat similar. And once this flyby is conducted, we're going to have our first images of this unusual dark comet. Although here it might be still difficult to tell things apart. It's only 30 meters in size, or about 100 feet in diameter, and it does rotate really fast. It takes only 10 minutes to spin once. Nevertheless, by 2030s, we might finally have our definitive answers. And even more intriguingly, on June 1st of 2024, this unusual object is also going to be at its closest distance to Earth in the last few decades. It's going to be approximately 4.5 million kilometers away, but that's enough for maybe James Webb to take a look. So hopefully someone out there with access to the James Webb and interest in asteroids is going to point the telescope at this object and potentially finally see outgassing after all, which will very likely directly confirm the existence of these dark comets without even needing to go there. And that's because James Webb should technically see quite a lot of different compounds and quite a lot of different volatiles, including maybe water, CO2, and carbon monoxide. Or, if we see nothing, we might need a new mechanism to explain what's going on. But either way though, we have at least 6 of these right here in the solar system, and so Oumuamua doesn't really need to have any additional extraterrestrial, unusual, exotic explanations. On this channel, we've discussed quite a lot of different mysteries in the galaxy, in the Milky Way, outside of the galaxy, and basically in a lot of different areas of the universe. Some of these mysteries are still obviously unexplained, but in many cases, scientists have been slowly inching toward a possible solution. But the thing is, even right here in our own solar system, there are some really intriguing mysteries that even right now nobody can explain. Obviously, the most famous one is the hypothetical Planet 9, or at least the unusual gravitational effects detected in a lot of distant objects. But today we're going to be discussing a slightly different mystery that's actually based on a very intriguing hypothesis. Something that the scientists discussed approximately 1 decade ago, and something that did actually have a somewhat unusual explanation that not a lot of scientists accepted. But in this new study, the explanation actually becomes a lot more intriguing and actually based on some really solid science. And so, hello wonderful person, this is Anton. Today we're going to be discussing this unusual mystery of our solar system known as the Kudo hypothesis. Kudo hypothesis? I'm not sure. Basically, compact ultra-dense objects present in the solar system. And first, let me actually explain to you where all of this kind of started. I mean, technically it started with a lot of other studies, but the biggest discovery was with this asteroid you see behind me. This is the asteroid known as Polyhymnia. Technically, I guess 33 Polyhymnia, because this is the 33rd asteroid discovered back in 1854. The asteroid that was actually known because it had a very strangely eccentric orbit with the eccentricity of about 0.34 and also an unusual resonance connected to Jupiter. For every 9 orbits of Jupiter, this asteroid orbited 22 times. And just like a lot of other asteroids in the asteroid belt, this one was also studied using radar. It was also studied by observing gravitational interactions with the objects nearby. And over time, the scientists worked out its overall size and its overall mass. It seems to be approximately 54 kilometers or 34 miles in diameter, so I guess pretty large. But, strangely enough, it seems to have a relatively large mass, approximately 6.2 times 10 to the power of 18 kilograms. And the reason this is strange is, well, it makes the density of this asteroid ridiculously high. It basically makes the density approximately 75 grams per centimeter cube, 15 times higher than planet Earth, and, more intriguingly, higher than the densest material on planet Earth, the material known as osmium. The density for osmium is approximately 3 times lower, and this of course has no physical explanation. An asteroid with a small size but relatively high mass just doesn't really make sense. Although here, I guess a quick side note, a very important side note. Many of these observations were only based on measuring the gravitational influence on other bodies, which means that there is a possibility it might not have been very accurate. Mostly because this asteroid is much smaller than a lot of other ones nearby. And since early 2000s, no other attempts have been made to try to measure the mass of this asteroid. And so maybe, just maybe, the calculations were just wrong. But assuming that they're not, this essentially created this unusual hypothesis. The idea behind these very dense objects, or compact ultra-dense objects, that seem to exist in the solar system and seem to kind of contradict a lot of other assumptions. And there are some other papers that you can find in the description below that do go through some additional potential discoveries, including various comets, such as for example the 2011 comet known as Lovejoy, that surprisingly did not fall apart when it was very close to the Sun, once again assuming potentially high density. And actually this hypothesis goes even further. It even suggests that certain unexplained craters on planet Earth might have been formed by these somewhat small but somewhat massive objects. As a matter of fact, this hypothesis even suggests that the Tunguska event might have been caused by one of these objects. Essentially, ultra-dense but somewhat small objects containing much more mass than they should contain on the inside. But a lot of initial explanations in regards to what makes these objects so much denser than anything else were maybe not too convincing. For example, a lot of them seem to suggest that maybe this is some kind of an unusual dark matter. Or to be more specific, it suggested that maybe there is a bunch of dark matter hiding inside of these asteroids, dramatically increasing their mass and of course their density. And so by discovering these asteroids and potentially discovering collisions with these asteroids, we might be able to solve the mystery of dark matter. Okay, Anton, is this going to be another dark matter video, is what you're probably asking. No, it's not. It's really not. It's actually something much cooler. Turns out that maybe dark matter is not the best explanation. As a matter of fact, it might be one of the worst explanations because the new explanation kind of makes sense. So here's what a new paper from just a few days ago proposes instead. Instead of some hypothetical physics, it goes into the periodic table of elements. Ironically, focusing on the concept that's sometimes referred to as unobtainium. Basically, a type of an element that's extremely difficult to create or to obtain, and basically involving elements that are much higher in the periodic table. But turns out that even though we currently have 118 known chemical elements, with all of the higher elements essentially being extremely unstable and almost impossible to create on Earth, there are mathematical theories that propose a kind of a stability island that happens much higher up the list. Certain super heavy elements, much higher in the periodic table, are predicted to exist not just for a few milliseconds, but possibly become stable and possibly create materials in a similar way that we actually have materials that we're used to right here on planet Earth. And specifically here, there's a theoretical region around the atomic number 164 where this stability begins and where the elements should be able to exist without any problems. And so even though before that the elements are extremely radioactive and usually decay very quickly, once they reach the atomic weight of 164, they might actually physically become stable and no longer even be radioactive, with the math behind this so far being intriguingly good. And so the main premise in this paper is that maybe these heavy elements physically exist and are physically stable in a lot of different places out there. And more importantly, maybe these super heavy elements are actually the reason why this unusual asteroid Polyhymnia seems to be so extremely dense. And so instead of dark matter in this case, they actually propose regular matter, but like hypothetical super heavy matter that we just haven't been able to produce on planet Earth, but in this case could be hiding inside this asteroid. Here they essentially extrapolate the overall density versus atomic number and discover that one of these weird super heavy elements, in theory, could explain the density we're observing, with the elements of atomic number 164 potentially having a density of 36 to maybe 68 grams per centimeter cube. So not exactly the same as this asteroid, but very close to it. And so here the idea is that maybe there are actually a lot of these asteroids out there with extremely high densities simply because they contain a lot of super heavy elements on the inside, which increases their mass and their density overall. And the fact that this is right here in the solar system and could potentially be obtained after all, obtaining this unobtainium would obviously present a very exciting opportunity. Although here it's most likely some kind of a combination of different elements potentially forming minerals containing these super heavy elements. And so whatever the answer is in this case, it's definitely super exciting. But it also means that we have to do one thing first. Someone has to once again measure the mass of this asteroid a lot more accurately, determining if the density is really that high. There is still a very high chance that all of this is based on a miscalculation, with a lot of other explanations involved in the compact ultra-dense objects, possibly having much more rudimentary explanations. Nevertheless, this whole concept of CUDO, or compact ultra-dense objects, does have quite a lot of support from a lot of other scientists, and you can actually find some of their more intriguing papers in the description below. For example, papers describing their properties, an entire series of papers describing other potential objects, and even objects outside of the solar system, and even explanations that basically go through some of the unusual craters right here on planet Earth that some scientists believe might have been created by something much denser than a typical asteroid. And that even includes craters on Mars and Mercury. And so yeah, all this means is that maybe just maybe, someone should take a look at this asteroid once again, just to see what's up here. If we do actually discover heaviest elements in the solar system hiding right inside this unusual rock, everyone is going to want to have a piece of it. And for all we know, maybe this is going to finally begin that space exploration era. Maybe we discover some incredible super heavy element that everybody wants to have. Space gold rush. Space kudo rush. Space super heavy element rush. I don't have a good name for it yet, but that would be cool, right? Let's start with the hypothetical question. Let's just say there is some kind of a rogue star that passes through the solar system. What's going to happen to everything in the solar system, and is Earth going to survive? And more importantly, how likely is it to happen anytime soon, and has it happened before? And though in some of the previous videos you can find any description, we did actually discuss certain stars that approach the solar system somewhat close. And here we're still talking about large distances, something like quarter to half a light year or so. What would happen if something passed much closer, approximately 100 AU, or the location where we find some of the farthest probes we've ever launched from planet Earth? And so what would happen if a star passed that close, and how frequent can we expect such events to occur? Well, first of all, we don't really have any physical evidence of anything like this ever happening to the solar system, but we can use statistics and a lot of different computer simulations to try to estimate how frequent these events are, based on our location in the galaxy and based on the overall speed of various stars, and of course the density of the stars in the volume of space. While also taking a look at various observations of runaway stars, or essentially stars that kind of crisscross the galaxy all over the place, and the stars that usually have the highest chance of eventually interacting with something. And that's precisely what the scientists in this recent paper did. In essence, they focused on computer simulations and statistical analysis from telescopes like Gaia that allow us to make relatively accurate predictions and, of course, even predict the motions of various stars for millions and millions of years. And so let's start with a chance. How likely is it? Well, when it comes to these hypervelocity stars or runaway stars, hundreds of which have been discovered in the last few years, the chance is practically impossible. None of them are headed our way, and the closest one is 4,000 light years away from us. These stars are usually produced because of some kind of a gravitational interaction or potentially supernova that suddenly gives them a kick, and though they will interact with some stars out there, it's not going to be the solar system at all. They're just going to be flying in every direction except for this way. And so just because of their relatively low number, this is something that we should not worry about at all. These types of fast-moving rogue stars, despite their unpredictability, are extremely unlikely to cross anything. But what about stars near us? Stars that are already relatively close to the solar system and could one day maybe intersect. And here we have to remember that space is very big. Despite the nearest star being 4 light years away from us, the overall volume of space around us does not actually have a lot of stars in it. If you were to draw an imaginary sphere around planet Earth that's approximately 100 light years across, a sphere with a radius of 100 light years, we would probably find at least 15,000 stars in the region, possibly as many as 60,000. It's actually hard to know exactly how many because some of them are very dim and difficult to see, but that is a huge amount of volume of space and a relatively small number of stars. And so statistically speaking, it will take roughly around 100 billion years for at least one of them to come close enough. And so for planet Earth that's going to be able to support life for maybe around 1 billion years, this statistics means absolutely nothing. It essentially means that in the next billion years, there's maybe like 1% chance that a star might come close enough. Might. Not necessarily will, but might. But let's assume that it does. What would happen to the planets in the solar system? And here the researchers essentially ran a simulation focusing on the number of surviving planets and focusing on the eventual fate of other planets. Naturally, there were a lot of different results, but some results were a little bit more likely. And well, it turns out that of all planets in the solar system, it seems to be Mercury that's potentially in most trouble. By being the least massive and the closest to the Sun, it has the highest chance of being affected by something, with some of the simulations resulting in Mercury basically colliding with the Sun or even colliding with another planet. But even though Mercury was most likely affected by all of this, in terms of the total number of simulations and the total number of results, surprisingly, in 95% of all simulations, nothing actually happened. As in, if the star passes through the solar system, even if it's relatively close, within the solar system, it seems to not affect much at all. It seems to not affect planets enough for them to be destroyed or for them to be disrupted dramatically. Their orbits might change a little bit, but in some cases, not by much. And so the chance for all planets to survive and to possibly still remain here unaffected is actually extremely high. But out of those 12,000 simulations, some did have somewhat intriguing results. For example, Venus, being a little bit less massive than Earth as well, sometimes seems to collide with other planets, including planet Earth. And so a collision between Venus and Earth is a potential possibility if there's ever a gravitational disruption in the solar system. Also, both Uranus and Neptune seem to have a tendency to leave the solar system if a massive star passes relatively close. But not Jupiter, not Saturn. Actually, Jupiter seems to have survived most of the simulations, sometimes even remaining the only planet in the entire system. Although interestingly, for planet Earth, another potential resolution is the collision with the Moon, or even the collision with the Sun. Both happened approximately 0.24% of all of the simulations, or basically roughly around 20 to 30 times out of 12,000 simulations. But the most likely resolution was basically Earth increasing its orbit a little bit and moving somewhere farther away from the Sun, possibly even to the outskirts, where it's a little bit colder. And this is maybe a little bit exciting because, in some sense, one of the reasons Earth is going to become inhabitable in 1 billion years from now is really because the Sun is just going to become too hot, very likely shutting down the geological activity on the planet and evaporating all of the water. You can actually find out more about this in one of the videos in the description. But if the planet is slightly farther away, it has a chance to maybe stay habitable a little bit longer. Which means that there is maybe a slight chance that a star passing through the solar system hypothetically might save planet Earth, extending its life by at least a few billion years. Although here you would have to get super lucky, because in a lot of their simulations, what basically happened to planet Earth is not really as pretty. It got kicked out to the Oort cloud, where everything kind of froze. With another resolution being a capture of the planet by the star. Here, if a star that's a little bit less massive than the Sun approaches the solar system closely, there is a chance it might capture planet Earth, while also disturbing other planets as well. The actual chance is once again very low, but it is there. But in the end, when we look at these statistics, this is not a scenario we should worry about at all, and it's super unlikely to ever happen. There's only 1% chance that within 1 billion years from now, there might be a star coming close enough, and inside that chance, there's only 1% chance, or even less than that it's going to affect the planet, or will dramatically shift the solar system, affecting something in the process. Although there's definitely one thing that is going to affect for sure. It might send a lot more asteroids toward the planet, which might cause some kind of an extinction event. But in the end, what the study helps us to visualize is just the fact how ridiculously big space is, how everything is super far away, and even when, for example, Andromeda and the Milky Way start colliding with one another billions of years in the future, even if there are billions and trillions of stars moving toward us, there's still an extremely low chance for any of them to collide with anything in the solar system, or to even pass relatively close. And this is something that's been worked out statistically many times, suggesting that we don't really have much to worry about. At least when it comes to stars disrupting the solar system. Everything else, maybe. This, not so much. One of the more intriguing questions and one of the more intriguing mysteries in regards to the solar system is of course a question in regards to how normal is this? Is this a typical star system with many similar systems in existence around the galaxy? Or is the solar system entirely unusual and somewhat weird? And although for many decades a lot of different scientists, including the famous Carl Sagan, sort of implied that we do live in a somewhat typical, very common star system with nothing special around it, a lot of more recent studies, and especially the study we're going to be discussing today, suggest otherwise. They do suggest that the solar system is really unusual, very unusual, and potentially extremely unique. Hello wonderful person, this is Anton, and so today we're going to be discussing the question of how ordinary is the solar system. With a lot of this based on a study you can find in the description with the title Framework for the Architecture of Exoplanetary Systems. The mathematical framework that sort of works out what are the most common architectures for various star systems, and where exactly does the solar system fit in there. But the question here is, why exactly did scientists previously believe that the solar system was not unique and not unusual? Well, the answer here is really simple. They didn't actually have a lot of examples to work with, and we're mostly basing this on the idea of what we think is happening in other star systems, based on the observations of various stars. But the reality is that in the last couple of decades, the technology has advanced so much that we're now able to see a lot of different star systems out there, and even detect various planetary systems, where we can then analyze what sort of planets are formed there, and what sort of a star this is as well. And so, because of the new advanced telescopes, we're now able to understand star systems much better than before. And it's really in the last decade, specifically following the initial discoveries from the Kepler telescope, which as you can see right here exploded right after 2014, when the scientists finally realized that a lot of these planets we're discovering are very different from anything in the solar system, and even those star systems seem to be very different. And so what exactly are those differences? Well, the biggest difference is that the majority of stars out there are usually binary, and some stars are even trinary or have higher multiplicities. But binary stars are the most common, and so the fact that the Sun is alone is kind of already unusual. Nevertheless, a few years back, NASA talked about this particular star system that about 3 years ago they believed to be the most similar in terms of structure to the solar system so far. So basically, out of thousands of star systems discovered, this one seemed to resemble solar system the most. This system is known as 55 Cancri. But even here, as you can see, it's not really that similar at all. Okay, it does have some kind of a gas giant, potentially somewhat similar to Jupiter, around the same distance, but the inner planets are very different. So here's what the inner structure of the star system kind of looks like. But I guess more importantly, one of these inner planets is also a gas giant. One of the closer planets known as 55 Cancri b. And so here you have a mixture of gas giants and terrestrial planets, but also spaced out very differently to what we have in the solar system. And even though the star itself is kind of similar, although this is technically an orange dwarf, also known as the K-type star, this is once again a binary system. And so if this is the most solar-like system discovered so far, you can imagine that everything else is even more unique and even more different. And as of today, approximately 900 various multiplanetary systems have been discovered so far, and not a single one has a similar structure to the solar system, or even similar planets. So for example, the closest star system with a lot of different planets around it is the system we've discussed previously known as Tau Cetus. 6 different planets in orbit around this very intriguing star. But all of them are potentially terrestrial or maybe super-Earths, and the system does not seem to contain gas giants, at least none confirmed so far. And naturally there are also no ice giants like Neptune or Uranus. Likewise, another similar star system, known as L9859, was also discovered to contain several terrestrial planets, but once again very different from anything in the solar system. And this is despite the star being very similar to our Sun. With one of the most Sun-like stars, the star with a relatively challenging name, TYC 8998-760-1, containing 2 giant planets that are clearly visible, but also not really possessing any other planets that will be similar to planet Earth, even Neptune and Uranus. With the farthest multiplanetary system discovered, the one you see right here, this is at a distance of over 13,000 light-years away from us, also containing predominantly gas giants, but in different locations and with different mass compared to the solar system. And more importantly, when it comes to the properties of various stars, such as mass and metallicity, there's really only a handful that's been discovered so far out of millions examined that seem to be Sun-like in terms of properties and in terms of age. So far, none have been discovered to contain similar planets. But that's of course based on previous observations from previous studies and from previous data releases. Now we have another study, mostly mathematical, that takes it even further. And here the main focus was architecture. What sort of star systems can form out there, and which ones would be the most common? And this is of course an important feature because we know that, for example, in the solar system, Jupiter's location and Jupiter's mass is very likely responsible for shaping everything else in the solar system, including potentially increasing or decreasing number of collisions everywhere else. And with 4 different gas giants on the outskirts, it's quite possible that the inner solar system is actually protected quite well. More importantly, things like water on planet Earth might have been the result of various collisions which could have been influenced by these gas giants. And so the architecture here plays a pretty important role. And here, this was a mathematical model that tried to basically create various star systems and find out which ones would be the most likely and most common. Something that would be actually a very challenging task for the modern telescopes, but something that computers can do pretty easily. And even though the initial assumption years ago was that the solar system structure was not unusual, this study suggests otherwise. So first of all, the most common seems to be the one that you see right there. This is actually what TRAPPIST-1 system is like as well, and this is what the scientists have so far found in a lot of different star systems as well. Planets of similar size, usually not too far away from one another, and very often relatively close to the star. And it doesn't just apply to red dwarfs, it seems to apply to larger stars as well. Although for larger stars, these would not be terrestrial planets, but instead would be gas giants. They also discovered that quite a lot of star systems were either mixed or even anti-ordered. In other words, mixture of gas giants and terrestrial planets, like the ones I showed you previously, or even star systems where gas giants are the closest and terrestrial planets are somewhere on the outskirts. But obviously the biggest surprise was that the ordered star system, the one similar to the solar system, was the least common, with something like 1% of all star systems appearing ordered out of all of the ones they've created, which of course implies that the architecture we have in the solar system is super rare. But the question is of course, why? Well, the simple answer here is that it's pure luck. But in order to find the more complex answer, we have to briefly take a look at how stars form. It all obviously starts with a relatively large gas cloud that has to reach certain density in order to start forming stars. For example, in case of a nearby supernova, the pressure from the wave here is going to create just the right density in the gas cloud to then suddenly start forming various stars along the shock wave. This is pretty much what the scientists usually observe in famous nebula such as the Orion Nebula you see right here. And so inside of this cloud, various clumps start to collapse, creating various stars. But at first, a lot of these stars form what's known as trapezia, named after the famous trapezium cluster in the Orion Nebula. But this is not a true cluster because these are stars orbiting around one another. And so technically this is a multi-star system, but the orbits here are not super stable. And so eventually some of these stars are going to get kicked out, some of these stars will assume more permanent orbits in, for example, binary systems, and some of these stars might have some other fate. What happens to these stars though is obviously pure luck. So they all have a slightly different initial start. And that's of course on top of a lot of other activity, such as turbulent gas or a lot of whirling material that essentially interact with all of the material nearby, growing larger, forming planets, but also gravitationally pulling on one another and sometimes losing some planets because of gravity. But more importantly, they all essentially end up with very different initial conditions, and depending on the mass and metallicity, will also produce different planets with a different arrangement overall, which is precisely what the scientists already can observe inside the trapezium cluster. And so because of this interaction, or technically even conflict between stars, when all of this is over and when they actually assume permanent stable orbits, or go on their merry way, they're going to end up with somewhat different final results. And on average, most of them will have similar planets, some of them will have mixed planets, quite a few of them will have planets in opposite order, and a very small fraction is going to have ordered planets like the solar system. And so it's really the cloud that kind of decides everything. The molecular cloud and the interaction inside of it is going to produce very different star systems in the end. And so essentially all of this is just pure probability. But for some reason, the probability of having solar-like structure and of course solar-like planets is really exceptionally low. In their study they actually list a few more reasons you can explore by yourself by looking at the link in the description. But in the end, it's really all about the formation process and how, unusually, star systems like the solar system just do not form very often. So a pretty cool discovery and definitely something to think about. But the question is, of course, does that actually answer the questions of life in the solar system? Well, that's not something we can connect just yet, especially because we haven't really found any signs of life around other planets or around other star systems, or really even right here in the solar system. So it's not something we can answer, and the speculation in this case, I guess that's just not my thing anymore. Hello wonderful person, this is Anton, and today we're going to discuss some of the new updates from the outskirts of the solar system. Some in regards to the New Horizons mission, and some in regards to what the scientists discovered here not so long ago, potentially redefining our understanding of what the solar system is like. But I guess first, a bit of a good news. NASA officially confirmed that the New Horizons mission is going to extend its operations, specifically focusing on planetary studies, all the way to 2029. And this is of course great because a few months ago, at first it wasn't clear if this mission might actually be over or might potentially be changed into a solar-based mission, essentially studying the Sun. But it looks like NASA got convinced to continue this as a planetary mission, exploring the rest of the Kuiper belt. It of course made no sense to finish this mission early, especially because this is the only mission we have so far away from the Sun, with a very powerful camera, able to capture a lot of different images of different objects from angles that would be otherwise unavailable to us. And so for as long as the New Horizons mission is still inside the Kuiper belt, it's going to remain active. But by 2029, it's expected to leave this area, reaching the mysterious Oort cloud. But interestingly, because there's still some fuel left on the craft, it's still able to change its course for a potential intersect with something else. And so in the last few months, various teams of scientists have been actively trying to discover another potential trans-Neptunian object similar to Arakoth that was explored back in 2019. And so by tracing the trajectory and by essentially looking ahead where it's headed in the next few years, teams of scientists using powerful telescopes on the planet have been trying to find other large objects that can serve as another flyby. But many of these objects are barely visible. Most of them are expected to be a few kilometers across, but are barely producing any light at all. And so in order to see if there's anything here, scientists have been using a lot of more advanced techniques, such as one known as shift stacking. Basically stacking several images all at once in order to magnify any kind of light that could be somewhere in the image. But one of the recent studies also used machine learning techniques to try to discover anything at a distance of 60 to 80 AU from the center of the solar system. And intriguingly, they seem to have discovered 12 different objects, at least preliminary. 12 potentially massive objects, anywhere from 60 to possibly 80 AU away from the Sun, that, if confirmed, could potentially be explored by the New Horizons. Although if these objects are confirmed, this is a much bigger deal for a lot of other reasons. It basically suggests that there are a lot of different objects on the outskirts of the solar system, and the entire solar system could be actually much more massive than we originally thought. Ironically, this would also solve one of the mysteries of New Horizons. When the mission was collecting data, it was actually a bit surprising that it seemed to be bombarded by a large amount of dust coming from somewhere. And this dust should not be here, mostly because the probe is already really far away from everything. However, a presence of another asteroid belt farther away from the Sun could be one of the potential explanations to what's actually happening here. Basically right now what this implies is the presence of, I guess, a second Kuiper belt or another asteroid belt potentially containing even more asteroids we never knew existed. But more intriguingly, based on preliminary observations, there's also a suggestion that something massive is pulling on them and changing their orbits. And though naturally this could be the mysterious Planet 9, right now the suggestion is that it's a presence of some kind of a large asteroid belt. More large objects on the outskirts, possibly forming some kind of an anomaly on the outskirts. And if true, it would also explain the anomalous glow or extra light that was detected by the New Horizons and even the Hubble Space Telescope that was impossible to explain before. In this case, this would be the reflection from all of the dust and much smaller particles formed by the belt. And it cannot be the Oort cloud because that one is much farther away. But we also have to be really careful because so far this is all preliminary. As a matter of fact, similar studies from back in June of 2023 potentially only discovered one object, not 12. And so we don't really know what's going on here just yet, and will very likely take a few months more to either confirm this or to explain it in some other way. But if confirmed, at least one of these objects could become the next destination for the New Horizons probe. And speaking of its previous destination, so there are some other discoveries from the object you see right here, Arakoth. And specifically, it's based on the analysis of its surface, including looking at various features such as various mounts, and comparing the shape, the size, and the color of both the smaller piece and the larger piece. And while interestingly enough, turns out that both pieces are extremely similar. As a matter of fact, all of the mounts or all of the hills on both of the objects surprisingly seem to have very similar properties. And not just similar color or size, but even similar proportions and overall shape. With 12 different mounts discovered, it basically suggests that this entire rock must have been created through a very slow process of accumulation over time or extremely slow gravitational collapse. And based on the location of this object, basically the outskirts of the solar system, it's probably extremely common for a lot of similar objects. Basically, they all just kind of slowly coalesce over time and create a much larger structure. And this one is really big, 35 kilometers in length, 20 kilometers in width. And so based on the size, it is a little bit unusual that many features here seem to be practically the same. It suggests some kind of a universal formation technique that seems to apply to many of these trans-Neptunian objects. Today it's assumed that many of these objects potentially served as a formation of larger planets, and many of them are basically planetary remnants, or I guess failed planets. But a much more intriguing comparison is going to come from the Lucy mission that very soon is going to be exploring other asteroids that are much closer to home. It's actually going to be looking at the Jupiter's Trojans, many of which might have similar origins. But exactly what it's going to find here, only time will tell. At the moment, the data from Arakoth presents a bit of a challenge when it comes to the formation model for the entire solar system. Mostly because it's not clear why so many parts of this object seem to have exactly the same features. Same color, same size, same shape. I mean, obviously it suggests a universal formation of some sort, but exactly how all of this works is currently unknown. But if this is how various pieces of various planets were made, we definitely have to try to understand this better. I'm sure we'll find out more in some of the future studies. Okay, I was about to finish the video, but editing Anton here. Turns out that as I was about to press the button, even more discoveries have been made from the outskirts of the solar system that I basically have to cover too, because they're sort of all related. And one of them is from very well-known dwarf planets that we've previously discussed many times. Sedna, Gong-Gong, and Quaoar. All three observed with the James Webb Space Telescope that used infrared observations to make some unusual discoveries about what's on their surface. And so first of all, these are Kuiper belt objects, so they're actually really far away from the Sun, but they also have generally different orbits. Also, they're really large. All of them are approximately 1,000 kilometers across, and so just a little bit smaller than Pluto, but way larger than most asteroids out there. And so here, by using infrared light, it became possible to see certain hydrocarbons and complex organic molecules right on their surface. And these molecules are generally just a result of methane that's already here, interacting with the Sun and potentially a lot of other radiation, and forming other volatiles, such as for example acetylene and ethylene. And so quite a lot of these objects, so for example objects like Pluto, will usually contain a lot of these volatiles on their surface. But what makes these three objects kind of unique is of course their orbit. Sedna, along with Gong-Gong, have extremely elliptical orbits, approaching the Sun relatively close and then moving away from the Sun relatively far. So both of these objects spend most of the time far away from the Sun. Quaoar though is a little bit different. Its orbit is more circular. And so its surface gets irradiated a little bit different from everything else. And so based on these orbital differences, with Sedna being the most elliptical and Quaoar being the least elliptical or most circular, it became possible to analyze the amount of various organic compounds on the surface of these objects, comparing them to the amount of sunlight they probably receive. And so Sedna contains a huge amount of ethane, and also has a lot of acetylene and ethylene, whereas Gong-Gong has a little bit less, and Quaoar has even less. And that's because a lot of these molecules result from irradiation from the Sun, but also things like ethane would usually be converted into more complex molecules if there was more sunlight compared to if there was less sunlight. With Sedna also generally being a lot more reflective than Gong-Gong and Quaoar, but also generally containing a lot of other stuff that seems to be absent on the two other objects. But because there are so many of these molecules on the surface, and because they generally come from methane originally, something must also resupply methane to this surface. But also because these objects seem to look a little bit different from a lot of other similar objects, including Pluto and including a lot of other dwarf planets, there is also a suggestion that they might have a very different type of a history. Maybe they came from somewhere else, or maybe they were formed in an entirely different way. So definitely exciting observations, just maybe not a lot of answers yet. And last but not least, we have another announcement from the object referred to as 2002 MS4. And here, by observing this asteroid through the process of occultation of various stars, basically when the stars pass in front of the asteroid, With this being done several times from several locations, the team discovered that this asteroid seems to have an extremely large depression, potentially from some kind of an impact, 45 kilometers deep, and also about 320 kilometers across. Now this asteroid is also probably a dwarf planet. It's about 800 kilometers in width, so it is a very large object, essentially making this an example of one of the largest, or technically the largest craters on the outskirts of the solar system discovered so far, and the first example of a huge crater beyond the orbit of Neptune. Here, the rim of the crater itself seems to be about 25 kilometers in height. That would technically make it the biggest mountain in the solar system, even bigger than Olympus Mons. But what makes this unusual is of course the fact that these collisions were never expected to happen that far away from the Sun. We don't expect these powerful collisions so extremely far away, mostly because objects here move very slowly. And so either this object came from somewhere else entirely, or once again maybe there's something going on here that we just don't understand. I think it's probably that last answer. Hello wonderful person, this is Anton, and today we're going to be discussing some of the new updates about the object you see right here. The object that sort of resembles a comet, and even acts as a comet once in a while, and the object located right here in the solar system, but also the object that's not technically a comet at all. Instead, it's a massive volcano, one of the biggest volcanoes in the solar system, erupting several times every single year. But not the same as the volcanoes right here on planet Earth. Not a volcano that's going to be emitting a lot of very heated lava that's then going to turn into some kind of crust. Instead, this is an example of what's known as the cryovolcano, a volcano that ejects not hot magma or the ash from the planet's mantle, but instead very cold gases and a lot of ice from inside the much colder interior. Something that the scientists have been able to detect around a lot of different objects out there, including the iconic Enceladus, one of the moons of Saturn. And so in this video we're going to be discussing a little bit more about this phenomenon, about this particular object known as 29P, and what the scientists were able to achieve relatively recently. But I guess first, so what exactly is this object and where exactly is it located? Originally, this object was discovered back in 1927, and it was actually only discovered because it suddenly became extremely bright. Its magnitude back then was about 13, and it was one of the brighter objects visible in this particular part of the night skies. But it then decreased in luminosity by about 3 magnitudes, and already created a bit of a mystery. What exactly happened here? And so back then this was established to be some kind of a comet, but it turned out to be a comet that increases in brightness by as much as 1000 times, pretty much at least 5 to 6 times per year. In other words, it's basically some kind of a cyclical comet, or a comet that increases in brightness with relatively regular periods. But in order for this to be possible, this comet would have to orbit around the Sun really fast, at least 7.3 times per year. That's sort of impossible. It would be way too close to the Sun, with the scientists eventually realizing that something else was happening here. It wasn't just becoming a comet, some other phenomenon was happening on the surface. Especially because this brightness seemed to disappear within just 2 weeks, as if this object suddenly became super bright and then dimmed in just a few days. And back then, nothing like this has ever been seen before. And so eventually the scientists realized that first of all, this had to be some kind of a asteroid or cometary object relatively far away from the Sun. But second of all, the emissions that seemed to be happening every 57 days were probably the result of the actual spin of the object, not so much of its orbit. In other words, as it spins around, once in a while it exposes a different side to the Sun, and because of this seems to initiate some kind of a reaction on the surface. Although even today, it's not actually certain what exactly happens here. And further analysis established that this is what's known as a centaur. It's not a regular asteroid. As of today, only a few hundred of these objects have been discovered so far, and they're essentially very small icy bodies orbiting between Jupiter and Neptune, and very likely stuck in these orbits on semi-permanent basis. Today the scientists believe that they were probably captured from the Kuiper's belt, or basically from much farther away, even farther than Pluto, eventually being attracted to Jupiter, getting stuck in the orbit between Jupiter and Neptune for at least a few cycles. But because of the gravitational influences from Jupiter, these orbits are not permanent. For example, for this particular object, it's believed it might stay in this orbit for maybe 1,000 years or so, maybe 2,000 maximum, and will probably change its orbit after the year 4000. And so this is a somewhat dynamic region where many objects exist for a few thousand years and then migrate somewhere else. Some of them might even become moons of other objects, such as the moon Phoebe that's believed to be one of these ancient objects that might have been captured by Saturn a few million or a few billion years ago. And in terms of the orbital similarities or even the properties, quite a few of these centaurs, including Phoebe, are somewhat related. And approximately 30 of these objects have been discovered to have cometary comas, with some potentially also being cryovolcanoes as well. But the ones that have been confirmed are 2060 Chiron, 60558 Echeclus, and the object we're discussing today, 29P Schwarzmann-Walkman, named after its original discoverers. So basically 3 potential comets, and only one, this one, that seems to be a very active and very periodic cryovolcano, with an orbit that's surprisingly circular for an object of its kind. No other comet known to us has a circular orbit like this, and being approximately 60 kilometers in diameter and taking approximately 15 years to orbit the Sun, all of these unusual emissions suggest that this object must be relatively new to this part of the solar system. If it existed here for several thousand years, it would not have these very powerful emissions so regularly. It's just not big enough to maintain this for such a long period of time. Yet it seems to be able to do so 7 times per year, every 57 days. And as I mentioned, sometimes the brightness increases by up to 1,000 times. As a matter of fact, one of the brightest eruptions was back in November of 2022. It seems to have released approximately 1 million tons of cryomagma, once again resulting in a major increase in brightness, making this object visible from really far away, with the brightness itself being created by light reflected off various particles of ice, or what's known as cryomagma. All of these crystals suddenly emitted by this object simply increase the brightness dramatically by reflecting all of the sunlight all at once. But up until this point, all of these emissions were still a little bit unpredictable. All of them would happen very suddenly, taking approximately a couple of hours to start, and would then disappear after 2 weeks. None of them have been predictable, and all of them were extremely sudden. And you can actually find out very detailed observations and pretty much everything we know about this object by following the page in the description, where the scientists from the British Astronomical Association provide an extremely detailed observation going back several years. And turns out that the recent eruption that happened in April of 2023 represented the first time ever that the scientists were able to successfully predict the eruption before it happened. In other words, by observing certain things happening on the surface, they were able to make a hypothesis predicting the eruption just hours before it actually occurred. Thus, to some extent, explaining how all of this might work and what drives this particular volcano to erupt so many times per year and produce so many emissions, which can hopefully help us explain how other major cryovolcanoes, such as the one on series, work as well. And so in this case, while observing this back in March of 2023, astronomers noticed that the light coming from the comet was extremely faint, faintest we've ever seen. And to the scientists, this was the sign that there was less gas leaking from the comet, suggesting that there was a lot of pressure building up inside, right underneath the crust, implying that the eruption was about to happen. And in this case, the scientists believe that as the sun weakens the crust, the internal pressure from within the comet causes the outer shell to crack, eventually producing a large enough hole to create a new cryovolcano, which then ends up shooting all of this into space all at once, representing a very intriguing cycle of buildup of pressure on the inside, release of all of this material all at once, and then a somewhat long quiet period for at least a few weeks. And because in this case the brightness increased by at least 10 times, once again this was a pretty powerful emission as well. Although what the scientists were really hoping to achieve are actual observations from the James Webb Space Telescope, specifically as the eruption happens. And unfortunately, even though they received some time on the telescope, it was only scheduled to observe this back in February of 2023. And this is when the comet was already fading, so the observation was during the quiescent period. Which basically means that we're not going to be discovering what's happening here just yet. But the scientists are definitely hoping to get even more time on the James Webb Space Telescope, because now they might have figured out how to predict these eruptions, and thus how to schedule the next observations a little bit better. They're really hoping to catch the emissions right as they happen in order to see what's actually happening here. So far, all we know is that this object emits these particles at really fast velocities of up to 1 km per second, and it does so extremely quickly, in just a few hours. And since a lot of these emissions also represent various primordial materials that essentially delivered carbon-rich molecules to planet Earth as well, in some sense this can also help us answer questions about the origins of life, and potentially a lot of other questions as well. But I guess more importantly, this is really the only such object we have in the solar system, and so its uniqueness makes this a perfect target for future observations. There's really no other cryovolcano that's as active as this. And you can learn more about this object in the video in the description from a few years ago. But overall, hopefully in the next few years, we might be able to get more observations and potentially answer some of the questions about what is actually happening here. How can it possibly increase in brightness so much, so suddenly, and then dim by up to 1,000 times for several weeks at once? No other object in the solar system does that. Actually, no other object we've detected ever does that. Definitely the strangest asteroid, comet, whatever it is, out there. Hello wonderful person, this is Anton, and today we're going to be discussing yet another really impressive three-dimensional map of an intriguing structure created by the astronomers relatively recently, showcasing what's known as the magnetic local bubble, which basically represents the magnetic field or the magnetic structure that surrounds the solar system and everything around us, and to some extent creates this unusual shape that you see right here, that also then produces quite a lot of intriguing effects on the surface of the bubble that have only been discovered in the last few years. But more importantly, this is an actual three-dimensional map that you can interact with, exploring each of the individual parts and each of the individual structures here, with some of the individual structures, and some of these individual structures we've previously discussed in separate videos that you can find in the description below. I think one of the more important discoveries in the last few years was the discovery of this unusual Radcliffe wave that you see right here, that represents this unusual ripple-like structure that many stars seem to surf on. The video in the description explains this a little bit better. But this recent map, this recent discovery, is going to help us answer a lot of really old questions about the origin of stars and the influence of magnetic fields in various galaxies. Because this is essentially a magnetic structure. What you see on the surface here, these are magnetic fields. And so what's actually coming from this recent study is the new technique or the new ability for the scientists to be able to actually see the magnetic field on the surface of this unusual local bubble. But I guess the first question is, what exactly is this bubble? And how did it even form? Well, because we're not really three-dimensional creatures and we're more two-dimensional creatures, I love using this map that you can find in the description that sort of shows us what everything around us potentially looks like. This was created by analyzing a lot of data from the Gaia telescope. Now this is in like tens or even hundreds of light years in distance, but if you start zooming in here, you'll discover this unusual feature known as the local bubble. There are a few smaller ones here and there, but the local bubble, or the local cavity as it's also known, is one of many different superbubbles located in the Milky Way. It's potentially at least 300 light years across and could be as big as almost 1,000 light years across. And as this bubble expanded over time, it pushed the interstellar gas away from the center, which then collapsed to form new stars on the surface of the bubble itself. The star that you see moving in the middle, that's basically our Sun. It most likely entered the bubble about 5 million years ago. And so the fact that we're almost in the middle of the bubble is sort of completely by accident. This bubble existed even before the Sun entered it. But it was most likely created by some kind of a pressure from some kind of an ancient supernova that potentially was caused by one of the stars located in the open cluster known as the Pleiades, also known as the Seven Sisters. This happened anywhere from 10 to possibly 20 million years ago, and as you can probably imagine, was an extremely powerful event. So powerful that it ended up creating this several hundred light years across structure. And even though the scientists recently discovered that a lot of stars definitely form along the surface of the bubble, with the expansion of the bubble creating the pressures needed for the stars to form, there are still so many mysteries about the structure, and of course its effects on the galaxy and all of the stars around us. But in all of the previous discussions of superbubbles and all of the previous models, the magnetic field for the most part was usually ignored. In other words, it mostly focused on the pressure or on the interactions of gravity on much larger scales. But most scientists are aware that this is not the reality. As this map shows us, the magnetic field here is quite prominent, and most likely plays a really important role in everything from distribution of gas, potentially guiding gas to various directions around the galaxy, or even forcing certain gas to form certain types of stars and certain types of molecular clouds. We've actually discussed various discoveries in regards to magnetic lines or magnetic fields in the Milky Way in some of the previous videos. Some of them should be in the description below. But in a nutshell, a lot of discoveries looking at all of this in radio light clearly established that the galaxies have really huge prominent magnetic lines, which potentially are responsible for a lot of effects we cannot explain. And so even though this particular supernova that happened 20 million years ago created a lot of powerful pressure, the magnetic fields that were created as a result also played a really important role. But what role? Nobody knows just yet. For example, they could definitely influence the overall shape of the galaxy, or at least the overall shape of certain molecular clouds. As a matter of fact, as I've discussed in that previous video, you'll notice that a lot of molecular clouds that produce new stars definitely seem to be located on the surface of the bubble itself. But some of them are located in the region with slightly different magnetic fields, at least based on these new discoveries and based on these new maps. What effects this has on these bubbles and how it changes the actual composition of stars and planets formed in there, that's one question nobody can answer just yet. And partially because it's been actually extremely difficult to find these magnetic fields and to study them in more detail. And so even though ESA's Gaia telescope can generally pinpoint the exact location of various stars or various really bright objects, it's not able to see the magnetic fields or anything in radio frequencies. And so instead the scientists had to rely on some of the older data from the Planck spacecraft that became really famous for creating the most accurate map of the cosmic microwave background. So it was actually able to see microwaves, which means that it was really good at looking at microwave frequencies. Frequencies that are somewhat relevant when looking for magnetic fields as well. With the data from the telescope being able to see some of the polarized light produced by various magnetically aligned dust particles present on the outer surface of this particular bubble. And in this case, the magnetic alignment of the dust particles allowed the scientists to then see the orientation of the magnetic field visible right here. And so when looking at some of the data from the Planck telescope, they were able to see all of this dust on the surface of the bubble, with a lot of the dust pointing in different directions because of the magnetic lines, which confirms an older assumption that as the bubble expands, the magnetic field seems to be swept up on the surface of the bubble and expands along with it. Which by itself is also a really important discovery, because it definitely confirms the influence of magnetic fields in galactic evolution and in star formation. And today, when using various computer simulations or supercomputer simulations in predicting the evolution of molecular clouds and star formation, most of these simulations generally ignore the effects of the magnetic fields. And not because the scientists don't want to include them, but actually because it's extremely difficult to implement them, because our general knowledge and understanding of these phenomena is, at the moment, extremely limited. We still have no idea what effects this all has on the galaxy and the production of various stars in various clouds. And so hopefully this new discovery will serve as the foundation for some of the new studies, specifically focusing on the effects of magnetic fields on star formation in various superbubbles. We probably still are not going to be able to model it just yet, but at least now we can sort of observe it, discovering what effects the surface of this bubble has on several different molecular clouds that exist around it and are visible right here. And so by trying to combine these observations with the observations of various types of star growth, we might be able to finally figure out how these magnetic fields influence the evolution of various stars, which is of course not something new and not something that we didn't know before. For example, several studies have already discovered that various types of wind shock, and of course the effects from the jet itself, dramatically change the formation of stars in just a few thousand years. And in certain systems, some of the stars get these tremendously large jets, which dramatically change what the final star is going to look like. And all of this directly depends on the magnetic fields around the star and the cloud itself. This particular object, known as the HH object, is particularly mysterious, and you can learn more about it in the video in the description. And so hopefully in the next few years, as we get more data, and as our observations become more complex, some of the new studies can finally start combining gravity, magnetic fields, and a lot of other interactions in various galaxies, and resolve some of these issues, and find the explanation for a lot of these mysteries of star formation. But as of right now, the entire field is still in its infancy. These are exciting observations, but there are just very few explanations as to what's really happening here and what created all of these shapes, or what's going to happen to them in the next few millions of years. So when I was writing the script for this video, I basically called it Pancake Comets, mostly because it's basically a really good explanation for what we're discussing today. But to be more exact, it's actually a potential solution to a lot of different mysteries that started a few years back and had a lot of scientists scratching their heads. The mysteries of the famous Oumuamua, the interstellar comet, and also the mysteries coming from the New Horizons when it flew by the now iconic Arakoth, basically snapping the pictures of the most distant object we've ever seen. But specifically, we're actually going to be discussing the shapes of these objects, because that's essentially what makes them so unusual and actually created so many mysteries that the scientists did not know how to answer. But this recent paper that we're going to be discussing today potentially once and for all answers why we have these unusual objects, but more importantly, explains Oumuamua, but also suggests that future objects coming from other star systems might also have these very unusual shapes. And so, hello wonderful person, this is Anton. Let's discuss pancake comets. Yeah, I think I'm just hungry. But anyway, the mystery goes something like this. In 2018, as New Horizons probe was approaching its new target, it actually started seeing it as this unusual bilobal shape, or basically a kind of a snowman. And as it flew by, it was able to capture these beautiful images, revealing that the shape is indeed bilobal and is very likely a result of a very slow collision between two smaller objects. Although I guess calling this smaller is maybe not really correct. This is still a pretty large object compared to objects like Oumuamua, but even compared to other smaller objects in the inner solar system. But what wasn't clear at first but became clear as the researchers analyzed the photos more and more is that these were not actually spherical objects at all. Or basically these were not two snowballs. Instead, these were basically kind of like two pancakes, but placed together side by side. And that sort of did not make sense at first, and actually didn't make sense for many years, but it is what it is. The shapes here were extremely strange. Or at least they appeared strange at first, until other researchers realized that quite a lot of different comets we've observed previously were actually unusually flattened as well. For example, the famous 67P or Churyumov-Gerasimenko comet that was also visited by another mission, if looked at from the sideways, also appeared a lot more flat. Maybe not as flat as Arakoth, but still flatter than a spherical shape. But more importantly, around this time we also finally detected the first ever interstellar object. Interstellar comet, that is. And that was of course the famous Oumuamua. And while based on the observations from its unusual changes in brightness, the first suggestion was that it was some kind of a prolonged cigar-like object. Or I guess in more common terms, it looked like some kind of a poop. And though the explanation here at first made sense, what didn't make sense is that this unusual object acquired tiny deceleration in the solar system and basically changed its trajectory just a little bit. Or in other words, it became a comet, except that there was no tail. And even observations using infrared light that can usually detect a lot of carbon compounds, in this case using Spitzer Space Telescope, discovered nothing. So there seemed to be nothing coming from the surface, and there was no outgassing at all. Yet it was changing the trajectory just a little bit, which is one of the reasons why eventually someone decided to explain this as, okay, this is an alien sail, or an alien solar sail, very likely tumbling through space. But because there was no evidence to suggest any of this, and on top of this, it was actually determined to have a surface color very similar to a lot of other objects, including Arakoth, or basically was slightly red, the researchers realized we just don't have a good explanation yet. And then we did. And several researchers explained this by reshaping the object. It was no longer poo-poo shaped, but quite likely a pancake. And a pancake that seems to emit tiny amounts of hydrogen because this was a pristine primordial comet. And that, even though it wasn't really accepted at first, eventually became the main explanation. It was shaped like a pancake and was actually producing outgassing that was just not visible with infrared telescopes. And mostly because of the materials on the surface and inside. Because this comet very likely came from extremely pristine conditions somewhere on the outskirts of one of the other stars. Or in other words, it has actually never interacted with stars. It never had cometary emissions before. And though we're going to discuss the best explanation for all of this in one of the videos coming out this week, actually maybe even tomorrow, and I guess a bit of a spoiler alert, it looks like we actually found more of these right here in the solar system. Today we're discussing not the unusual comets, but the shapes. Turns out these pancakes are extremely common. As explored in this study you can find in the description. But I guess the question is why? Well, the main answer is that in a lot of these more massive objects, once they acquire enough mass, they acquire the center of gravity, which then starts to kind of coalesce more matter, making them more and more spherical. Which is of course why the larger and larger the object gets, until a certain point, the more spherical it gets as well. But that is not the case for most of the smaller objects, or the objects really far from the Sun. The gravity process known as pebble accretion, which basically creates planets, does not really work when there is not enough matter. And so because of the much lower mass, a lot of smaller objects, especially the ones in the Kuiper belt, over 40 astronomical units away from the Sun, will usually lack gravitational forces and instead seem to interact with a lot of other forces, potentially static, but also very likely much weaker forces such as van der Waals forces, a type of electrical/chemical bond that's normally extremely weak, but does become prominent in these conditions where there is just no other forces. For example, one of the main discoveries in the last few decades is the fact that many asteroids we've explored, including Ryugu you see right here, do not seem to be spherical either. They're usually diamond-shaped, and are not actually rocks at all. They're just a collection of rubble held together by these van der Waals forces mixed with just a little bit of gravity. And as a result, they usually acquire really funky shapes. But one thing that becomes obvious for asteroids is of course the fact that they're usually also in more active regions with a lot of collisions and a lot of interaction. Because of this, their shapes become very irregular over time. Anything from the famous rubber ducky or 67P comet to objects like asteroid Eros, which seem to have very strange, elongated shapes. It basically looks like some kind of a long potato. And that's because over the years, researchers started to realize that depending on the location, the composition, and the overall orbit of the object, they'll actually dramatically change their shapes over time and will actually look nothing like what we thought they look in the past. And so for decades we thought that asteroids were just smaller rocks and would also be mostly spherical in shape unless they were extremely small. But in reality, they differ quite a lot and are pretty much unique in terms of shapes. But they also discovered that for objects much closer in the solar system, so basically the ones in the asteroid belt, they will very often have extremely different origin. Here, most asteroids very likely experienced a lot of collisions in the past, and for the most part might all actually be just leftovers from many different collisions over billions of years. And because there's also a lot of gravitational disturbances from planets like Saturn and Jupiter, they generally acquire different shapes from what is expected from a lot of other objects that sometimes become comets. Here we're talking about objects from the Kuiper belt, and so basically objects like Arakoth. And so this new study used a lot of simulations and mathematical analysis to finally come up with an explanation for what a lot of these objects on the outskirts of the solar system potentially look like. They're very likely all going to be pancake-shaped because of the way the leftover pebbles that remain here from the beginning of the solar system create tiny spinning clouds, eventually forming denser and denser objects and eventually collapsing into nothing but a pancake. In this case, the flattening is basically a redistribution of momentum, which is very similar in principle to how star systems form and why a lot of galaxies are flat as well. But in the case of Arakoth, two similar objects were in the vicinity, and so eventually they came closer and closer and created one large pancake. And because after the formation of the solar system, it's quite likely there was a lot of stuff left over in these faraway regions, it's also quite possible that most of the stuff formed these very unusual pancakes. But why do we not see them more often in the inner solar system? Why do most comets seem to actually be a little bit thicker? Well, the answer to that is of course the Sun itself. Even though it's believed that most comets coming from the Kuiper belt would very likely be flat at first, as they approached the inner solar system, they started to dramatically change in shape. Here's an example from 2006 of the comet 73P falling apart. And so here, these tremendous emissions from the surface completely reshape the comet in just a few months, because the sublimating ice in this case doesn't just become gas, but it becomes really powerful jets, which then affect the comet in a lot of different ways. And so these powerful jets can generally create a lot of different structures. And by the time we actually get a spacecraft here and take a picture, we essentially see a completely new shape. But in most cases, the flattened shape is still sort of there. It's not always super flat, but most comets seem to be flatter than asteroids. And though asteroids also experience a lot of other forces, including Yarkovsky forces, which usually change their spin and then reshape them even more, for most of these pancake objects, they tend to experience something entirely different. Mostly sudden emissions from the surface, and then eventually tidal interactions with either the Sun or in some cases some kind of a planet, such as the famous Shoemaker-Levy 9 comet that collided with Jupiter in 1994 by basically turning into a bunch of tiny fragments that created a kind of a chain that you see right here.
which naturally implies that these pancakes are very likely extremely fragile. But this would very likely only work for smaller objects. I guess they would have to be less than 100 kilometers in size, because larger objects, such as the famous Eris, the most massive dwarf planet in the solar system, would be much larger and much more massive, eventually turning spherical as well. And though right now we don't actually know where exactly this limit starts, if we go by Arakoth, it can definitely be at least 30 kilometers across. But obviously studying more similar objects would help us resolve this mystery even faster. And I guess going back to Oumuamua, this potentially finally explains pretty much everything about it. It might have been some kind of an object from the equivalent of the Kuiper belt of its own star system, and very likely formed in a similar way through this unusual pancake pebble accretion. In other words, it was formed not really because of gravity, but because a lot of these ancient pristine particles coalesced into a pancake shape. Which actually means that Oumuamua is still potentially one of the most exciting objects to have visited the solar system in a very long time. And yeah, it would be really nice if we could find a way to somehow, maybe, visit it. I mean, there are some ideas for these potential retrieval missions, one of which we discussed recently in the video in the description. But since it's still in the solar system, maybe there's still some hope. But anyway, at least for now, this paper seems to have explained why so many distant objects seem to be flat, and how this probably works for a lot of objects on the outskirts of various star systems.
It's been quite a while since we've discussed dwarf planets, Pluto, Eris, Haumea, and so on. And it looks like in the last few months we had some really interesting discoveries from all of them, potentially helping us understand their origins, what sort of happens at the outskirts of the solar system, and also making a few surprising discoveries in the process, especially when it comes to what's inside of these objects and how they're structured. And so, hello wonderful person, this is Anton. Let's talk about some of these new discoveries. But also, I guess let's start with maybe a bit of a history. This all started in 2005. Three now well-known researchers, Chad Trujillo, Mike Brown, and David Rabinowitz, accidentally discovered a very unusual object really far away, way past Pluto. This was the discovery of Eris, the object that resembled a tiny moving pixel, but was obviously much larger than a typical asteroid. It also had a very unusual orbit, a very eccentric orbit, an orbit that took approximately 560 years, but for most of its lifetime, it stayed on the outskirts as far as 97 astronomical units away from the Sun. And though, as you can see right here, it's technically even smaller than the Moon, the discovery of similar objects in the following years led to what's known as the planetary debate, or the Great Planet Debate, that basically resulted in Pluto becoming not a planet. So yeah, it was all Eris's fault. But nevertheless, it was still a really exciting discovery, mostly because it was super unusual and even more massive than Pluto. Though there were obviously quite a lot of unanswered questions. For example, what exactly are these objects? What's inside of them? And though this right here is just a simulation based on some predictive models, a few years after that, New Horizons was able to physically visit Pluto, making a lot of interesting discoveries. This was a much more active object than we ever imagined, and was even geologically active in its own way. It had a lot of cryovolcanism, it potentially even had some kind of a version of a plate tectonic activity. Mostly because a lot of surface here was relatively new. Some of these features are only millions of years old, not billions as expected. But when comparing observations from Pluto to other similar objects, other dwarf planets, even there things seem to be a little bit different, especially based on what we seem to see from the surface. With all of these observations leading back to the question of how do these objects differ from one another and from other planets? They're clearly not the same, and they clearly have a lot of physical differences, and they might have been even produced in a completely different way. So do we have any answers? And there's at least one recent paper from the original discoverer of Eris, Mike Brown, and his colleague Brian Butler, that provides us with some potential answers for most of these unusual objects. Mostly based on observations of how these objects orbit around their moons, which allow the scientists to determine the overall center of mass, in order to then figure out what's maybe inside of them and how the mass is distributed as well. Which then also allow them to discover how most of them seem to have been formed. And that of course includes Pluto and its moons. With another paper around this time, mostly focusing on Eris and basically its mysteries. And some of the first exciting discoveries are from Eris itself. it seems to be somewhat different from Pluto in one major way. It seems to have differentiated into separate layers, kind of similar to a planet, very likely containing an icy shell and a rocky core, but also very likely lacking in a lot of different types of ices, or volatiles as they're also known. In other words, unlike Pluto, it seems to have more planetary features, including physical layers inside, that potentially interact in a somewhat similar way. So if we go back to calling Pluto a planet, Eris also has to be a planet as well. With all of this very likely being a result of an extremely powerful collision billions of years ago. Or basically very similar collision to the one that created Earth and the Moon. Although I guess on a much smaller scale. But I guess much more importantly, this also resulted in the formation of Eris's moon. Its tiny moon, Dysnomia, that you see right there, that has a diameter of 615 kilometers, is also a somewhat intriguing object, specifically because it's really large. It's about 1% the mass of Eris, but intriguingly has a very similar mass ratio to Earth and the Moon. And so here the parallels are very intriguing, except that obviously there's one major difference, or maybe two. The distance to the Sun, and of course the overall size. Since it's even smaller than the Moon itself, this is basically like a shrinked version of our planet and its own moon. With the additional discoveries suggesting that not only is this a rocky core surrounded by ice, this rock also seems to produce radioactive heat, once again very similar to planet Earth, basically making the crust convective. And that implies a lot of things, including maybe some kind of an ocean underneath. Maybe life? Okay, too far. We don't really know anything about that just yet. But still, somewhat exciting initial propositions. Although don't forget, this is all based on models for now, not physical observations. All of this heat would then also create a lot of activity on the surface, with lots and lots of ice activity, possibly even more than what we see on Pluto. I mean, here for all we know, Eris might have an active geological cycle that's visible with extremely young surface features. So yeah, can we have a mission to Eris, please? Thank you. Although here it would still be different from Pluto because Pluto doesn't seem to have the same things on the inside, and so its surface acts a little bit different as well. So these are not the same objects in terms of properties. Obviously studying both in more detail would be super exciting, but unfortunately no one is planning any missions to any of these objects. But then we had another exciting discovery from a slightly different object or a slightly different dwarf planet, Orcus and its moon Vanth. Orcus, discovered back in 2004, is sometimes referred to as anti-Pluto because of its orbit. It actually has a very similar orbit to Pluto, but kind of like on the opposite side, or I guess 120 degrees from Pluto. And so its nickname anti-Pluto is somewhat accurate. Although it's much smaller in size, at just under 1000 kilometers in diameter. But a much more exciting discovery here is, I guess, what you see right here. Its moon makes it wobble quite a lot, and that implies that the moon is also massive. Turns out that it's approximately 16% the mass of Orcus, and that ratio of 0.16 is even higher than Pluto and Charon, which only have a ratio of 0.12, implying that Vanth and Orcus have the highest mass ratio in the entire solar system, way higher than anything we know, and more importantly presenting a bit of a problem. It's unclear how this formed, with only one potential explanation making sense. Once again an impact, but an impact that leaves behind a relatively intact impactor. Basically think of an object that hits something, but instead of falling apart or being destroyed, it sort of grazes the surface and then assumes the orbit around the other object. But also implying that this impact very likely created additional satellites that are probably still orbiting there as well, kind of similar to what Pluto has as well. It has all of these additional moons in its orbit. But then on top of this, they also looked at other dwarf planets and of course other moons. And overall made very similar discoveries there as well. And this essentially implies that this seems to be some kind of a universal phenomenon that's responsible for creating these very large moons on the outskirts of the solar system. It usually involves a somewhat, I guess, weak impact and potentially some kind of a grazing impact that instead of destroying both objects and mixing them into one, produces some kind of a leftover, extremely similar to how we believe the moon was formed from the collision of planet Earth and Theia. And that's actually why this is an exciting discovery. It implies this might be extremely common, or at least common for the outskirts of the solar system, but may also be common obviously elsewhere, in other star systems. And if it's common in other star systems, there might be other planets, similar to Earth, that have very massive moons that play an important role in stabilizing the planet and basically making it habitable over time. Although obviously there are still some mysteries about all of this as well. For example, when it comes to Haumea, one of the stranger dwarf planets out there, it is a little bit difficult to explain how everything formed here, including its 2 moons, its unusual rings, and its unusual flattened shape. It's also unclear why almost all of these objects have moons. I mean, this seems to be super common, and way more common than for actual planets. So there's definitely some kind of a mystery here that we currently cannot answer. Here, as you can see, out of these 10 objects, 8 have moons. But 2 other ones are just a little bit dark or a little bit too far away to confirm moons. They might have them too. So yeah, we have a new mystery of dwarf planet moons. Dwarf moons, I guess. But speaking of mysteries, at least one mystery of these unusual objects and their moons has been solved. The biggest dwarf moon out there, Charon, the moon of Pluto. Here the scientists finally solved the reason why it has these unusual scratches, or basically these unusual long depressions, going all the way around the moon. They literally seem to be stretch marks, and specifically stretch marks from something underneath. Once again, a liquid ocean, but the ocean that no longer exists because it completely froze. And so here the scientists were able to explain how the freezing of a relatively large underground ocean would slightly expand this object, forming large stress marks on its surface, because as you know, water expands as it freezes. And this is of course really exciting because it tells us that there was an ocean here, and then it tells us what happens when these oceans freeze and how they affect the surface at the end. Now there's still maybe some liquid water left here and there because there also seem to be signs of various cryovolcanoes, but for the most part it seems to have been frozen for a long time. But maybe not Pluto, because here there was another interesting discovery. Here, by analyzing surface features and looking at a crater known as Kiladze crater, scientists realized it might actually be a sign of an ancient supervolcano. A volcano that erupted millions of years ago and seems to be still kind of active. But unlike your typical Earth volcano, it was not producing lava, it was producing water. Or more technically, liquid cryolava. Basically a mixture of water and potentially things like ammonia that keep water slushy or almost liquid at super low temperatures and pressures. And signs of all of this was discovered around the crater. Signs of recent ammonia and signs of recent liquid water. And so it's most likely an ancient volcano. And obviously the signs of this water indicate that there might still be some kind of an ocean underneath, or at least partial ocean, as it's also believed that most of the ocean has already frozen as well. But if something like this was discovered on Pluto, because Eris seems to be more active, we can only imagine that its surface is going to be even more extreme. So yeah, NASA, can we go to Eris please? Thank you.
Hello wonderful person, this is Anton, and today we're going to be discussing some new research and new discoveries coming from within the solar system. More unusual unexplained light that seems to be created by something within the solar system, but currently does not really have a very good explanation. There are some propositions, but the scientists still are not entirely sure what's causing this extra light. And so let's talk a little bit more about this recent discovery, and actually some of the other previous discoveries on this topic as well. Because this is obviously not the first time the scientists discover some unusual glow somewhere out there, and they're not 100% certain what's behind the phenomenon. And the most famous type of the glow that you can actually find in the solar system and even see yourself without any telescope is the glow that's referred to as the zodiacal light. I think this image right here is one of the better representations of what it kinda looks like, and it's basically something that you can pretty much see from any part of the planet if you find yourself in a dark enough environment. And the thing is, for many years the scientists believed that a lot of the zodiacal light and a lot of basically the glow that's produced here might be caused by tiny pieces of meteoroids, or maybe even tiny pieces from various comets that get deposited over time and remain in a certain orbit somewhere between planet Earth and the asteroid belt. But there is a video on the channel from possibly just over a year ago that explains how our assumptions about this have changed. Mostly because of the observations from the Juno probe that was traveling from planet Earth to its current orbit around Jupiter. Over time, the mission discovered some really unusual properties of a lot of the particles that cause the zodiacal light, with the orbital parameters suggesting that it actually is coming from only Mars. Which of course implies that the zodiacal light could actually just be the Martian dust. And it seems to make a lot of sense, and a lot of the recent research supports this idea. But that's of course just one type of the glow that seems to happen somewhere around the solar system. Very recently, we've also discussed this other type of glow that was discovered by the iconic New Horizons probe that you see right here, when looking at the light much farther away from planet Earth, basically at the outskirts of the solar system. And in this case, after passing Pluto and after it reached some of the more distant parts of the solar system, it actually started seeing some other glow. Unusual excess optical light that was approximately twice as bright as the scientists expected. Now at the moment it's not entirely clear what's causing it, but there have been some major propositions suggesting either that there are more galaxies in the entire universe than we originally assumed, or, as you can learn from that video in the description, that strange glow could hypothetically be caused by the particles we've been looking for a very long time, axions, which would also be a direct proof of the observations of dark matter. But at the moment, all of this is kind of preliminary, and so we have these two types of glows in very different parts of the solar system. But now the scientists have discovered something else, the third type of a glow, also kind of currently unknown. In this case, this was part of a program known as SkySurf, which essentially represents the largest collection of Hubble images meant to study the mysteries of the night skies. And in this case, after analyzing roughly around 200,000 Hubble images and doing very thorough calculations, removing a lot of extra light that we already are aware of, the scientific team discovered that there was still some light that was left behind, the light that was only present in the inner solar system and did not really have a very good explanation. But it's very dim, very difficult to detect. The scientists in this case compared this to having like 10 individual fireflies in the entire night skies. But it's there nevertheless. It's also much larger in terms of volume than the zodiacal light and is distributed farther away, but is a lot dimmer than the zodiacal light or even the light discovered by the New Horizons, representing some kind of a local phenomenon that's producing the glow inside the solar system. But discovering all of this was really challenging, and mostly because of the way that Hubble takes images and how we process them afterwards. More than 95% of all of the light that's in the Hubble image usually comes from distances much closer than 1 light year within the solar system itself. And so in the early Hubble days, a lot of these extra photons were actually discarded because the scientists really wanted to focus on these distant objects or to take these glorious pictures of distant galaxies that would otherwise be invisible, with this discarded information known as sky photons. But these sky photons obviously contain a lot of information that could be useful that was discarded over time. For example, it could be some really faint objects that appeared to be part of these sky photons but that were just invisible after the processing was done. And so that's pretty much what SkySurf wants to do. It wants to use the information collected by Hubble for several decades to essentially rediscover things that might have been lost over time. And in the process, by conducting the research with 200,000 different images, they did discover a lot of that extra light. The light that could not really be explained by these extra galaxies, because they actually confirmed this by trying to see if there were any galaxies missing, and unfortunately, the galaxies did not really show us anything. So the light must have been coming from within the solar system. And so even when removing every known source of light, there was still some extra glow left without any current explanation. Now this is still a preliminary discovery, but if this discovery is confirmed, it essentially means that there's some other additional architecture that seems to be part of the solar system and seems to create these effects. And so maybe all of this extra light is caused by thousands and millions and even billions of various comets that go around the solar system, creating long tails, with the icy particles that are left as a result potentially being responsible for this extra glow. So maybe it's some kind of a cometary dust cloud. And since comets do actually have very diverse orbits around the solar system, it would explain why we're seeing this glow coming from everywhere. But naturally, comets are not the only explanation. As a matter of fact, other explanations of other glow could also come into play here. Just like the zodiacal light, this could in theory be also created by planetary interaction and the planets inside the solar system. For example, maybe the interaction between Jupiter and its moons. Or more intriguingly, just like the explanation from the New Horizons, for all we know, maybe this glow is actually also coming from mysterious axions, but actually located right here in the solar system. Or in other words, maybe we are seeing dark matter. Although dark matter has also been used as an explanation for the excess glow right in the middle of the Milky Way itself, and so sometimes it's just used as a kind of a placeholder. Basically, when we don't really know what's causing extra glow, sometimes scientists speculate that maybe it's dark matter particles. In this case though, a lot of recent examinations revealed that it's probably ancient pulsars, ancient neutron stars, potentially coming from a distant galaxy behind the Milky Way itself. I think there's a video in the description that explains it a little bit better. And so at the moment, it's just another intriguing discovery of yet another mystery right here in the solar system. The most likely explanation is probably cometary particles, but for all we know, future studies might actually discover something else more intriguing, just like it was discovered with the zodiacal light as well. And so even though a lot of scientists originally assumed that all of this was just meteoroid dust, it turned out to be coming from Mars and not really meteoroids. And so here I'm actually excited to hear future explanations for this unusual new glow that the scientists discovered in the Hubble imagery. But at least for now, that's I guess all we know. It's just a very recent discovery, and there's just not enough data or information to figure out what's happening.
So today we're going to be discussing a planet we normally don't talk much about, Mercury. And mostly because of some of the recent discoveries coming from Mercury that the scientists were able to make in just the last few months. But before we start the video, I actually wanted to start with the picture. Because in this case, you're not actually looking at Mercury, you're looking at the moon. Here's what the picture of Mercury looks like, and the reason I wanted to do this is basically because there is an unusual similarity between these two objects. The moon and Mercury, in terms of the actual surface properties, are generally quite similar. And so in this video we're going to be discussing some of these studies that actually use these similarities to learn new things about Mercury as well. Anyway, hello wonderful person, this is Anton. Let's finally discuss new discoveries and new revelations about Mercury, mostly done by the recent passage of the Bepi-Colombo mission, the Japanese-European collaboration that has recently done a major flyby, in the process taking some of the most detailed pictures from the surface of Mercury, as the mission flew by at just 236 kilometers away from the surface of Mercury. But that's of course just the beginning, because the main purpose of the mission is to eventually assume an orbit around Mercury, starting its official scientific mission. But even before that, it was able to take some really impressive pictures, which in the process allowed the scientists to basically start naming new craters detected on the surface. One of them right there is named Manly, after the famous YouTuber Scott Manley. Oh wait, sorry, no. Actually after someone I've never heard of before, Edna Manley, a Jamaican artist often considered to be the mother of Jamaican art. Yeah, I didn't know that. Anyway, the point is that there are a lot more features with different names now that have now been officially approved by the Astronomical Union. But a lot of other geological features became visible as well. For example, a lot of different basin floors flooded by various types of lava, clearly demonstrating history of volcanic activity on the surface of this planet. In the future, one of the studies is going to be measuring levels of carbon in these areas, which are usually visible because they don't reflect as much light, in order to discover what sort of minerals are hiding here and to learn more about geological history, in order to then compare it to the moon, which is actually how a lot of these studies are going to be conducted. Because of the geological similarities of Mercury to the moon, many of the studies often focus on examining the surface of these two objects and then trying to see what's actually different. For example, in one of the recent studies, by using approximately 3,000 images obtained by the NASA's Messenger probe, scientists were able to discover the amount of various boulders present on the surface of both objects. Although because the Mercury's pictures are much lower in resolution, in order to make the study less biased, the scientists essentially lowered the resolution for the moon pictures as well, in order to essentially compare the total number of various large rocks, boulders, on the surfaces of both objects. And well, it turns out that the surface of Mercury contains way less boulders than the moon, on average approximately 30 times less, naturally suggesting that different types of processes happen on both objects despite a lot of similarities. And there are three potential explanations to why this is so. For example, because Mercury is much closer to the Sun, and because the Moon is also directly connected to planet Earth, both objects probably receive a much different amount of micrometeorites hitting the surface. On the surface of the Moon, when they actually hit the surface, it's very likely at least 15 times slower, with some of them also potentially going to Earth instead of the Moon. But on Mercury, because of the proximity to the Sun, the velocity is much higher, and so the micrometeorites are able to destroy and grind these boulders over time much easier. On the other hand, The regolith itself seems to be much thicker on Mercury compared to the Moon. And that means that even when the collision happens, in order to produce various boulders, it does not result in as many rocks as what we usually get from a typical crater on the Moon. Lastly, the temperature fluctuations on the Moon are much lower than Mercury, and the amount of thermal stress experienced on the surface of Mercury potentially results in the additional abrasion and destruction of various boulders. The Moon experiences approximately 3 times less thermal stress compared to Mercury, and as a result of this, a typical rock can easily last at least 100 million years on the Moon. On Mercury, it shrinks to just a few million years in comparison. But all of this thermal stress on Mercury causes a lot of other features as well that we actually have not seen anywhere else in the solar system. For example, one of the images from Bepi Colombo shows us a strange feature known as Bigelow rupes, one of many very long scratch-like or stretch mark formations formed as a result of the planet cooling down and contracting over time. This one is about 600 kilometers in length and actually cuts through the newly named crater that you see right there. Something that's visible in a lot of different formations on the surface of Mercury. And this is actually a result of the planet cooling down and contracting, which then forms a variety of very unusual features. But sometimes they seem to be much younger than the craters. Or basically they'll be visible on top of the crater instead of being underneath. And that implies that these unusual scratch marks must have appeared afterwards. They seem to be much younger. And so these formations, known as lobate scarps, features only existing on Mercury, have now been detected in a lot of different locations, many of them potentially as young as just several 100 million years old. Which actually suggests one thing. Not only did Mercury already shrink by about 7 kilometers in radius over the last 4.5 billion years, these formations suggest that it's actually still shrinking and still becoming smaller. And we see this through the increase of these scratch-like or stretch mark formations visible pretty much everywhere on the surface of Mercury. And what's even more surprising is that most of these unusual formations seem to be much younger at under 300 million years old. In terms of size, they're usually about 1 kilometer wide and anywhere from 10 to 150 meters deep, but tens or even hundreds kilometers in length. And so the implication that the Mercury is still shrinking is definitely there. But why is it shrinking is another question. And some of the potential answers to this might come from a study of something entirely different. The amount of various volatiles visible on the surface of Mercury. Now technically this planet should not have any ices or any volatiles on its surface. They should be already vaporized by the sun. But in reality, it's extremely rich in volatiles, visible as these white and blue formations on the surface, very likely representing things like water, carbon monoxide, sodium, and so on. And as many of them break through the surface, they form something that we don't see anywhere else in the solar system. Very strange collapsed pits, unusual mountains, or sometimes unusual vents similar to volcanoes that seem to be a result of vapor coming from underneath the surface. But unlike a typical volcano, they'll often be surrounded by remnants of various ices, visible as bright materials around the formation. And technically they should not be here. They should have been eroded a long time ago and evaporated in the process. Yet many of these formations do exist in a lot of locations on Mercury, but predominantly in much darker areas, specifically correlated with what the scientists refer to as low reflectance material. And though it's not entirely clear what these are, they're most likely a result of sublimation that causes a lot of the surface to sink or potentially suddenly release a lot of gas similar to a typical volcano, but not as explosive as volcano, maybe somewhat similar to what happens on Ceres. We know that Ceres, for example, seems to have signs of somewhat similar formations. And that of course implies two things. One is that Mercury is clearly relatively rich in volatiles, so things like, for example, ices like water and carbon monoxide, and was thus maybe created much farther away from the Sun, but was eventually transported to its current orbit through some kind of a gravitational interaction. It's unclear what it was, but it could have been Jupiter. And as a result of its orbital change, all of the volatiles underneath started to eventually sublimate, producing these unusual features and these unusual cracks, and potentially causing the planet to shrink over time. And interestingly, a lot of these compounds escaping from underneath are directly visible as unusual tails around Mercury. The most famous one is the sodium tail you see right here, which makes it appear as a type of a comet. But there are other compounds inside Mercury's exosphere or very thin atmosphere that also escape from the surface, creating additional tails. For example, there's another one that seems to be more violet or purple, produced entirely by calcium. But interestingly, by studying the exosphere, it might become possible to understand exactly what's happening underneath Mercury and what's causing it to shrink and what's coming from underneath. Right now, the analysis suggests that the exosphere is approximately 40% oxygen, 30% sodium, 20% hydrogen, and 6% helium, with a little bit of potassium, argon, neon, carbon dioxide, water, nitrogen, and xenon present in there as well. And so by studying the exosphere, which is very likely produced by the emissions from underneath, it will become possible to understand what's happening here. Right now these are just preliminary observations, but we might learn more in September of 2024 when the Bepi-Colombo mission comes for another round. It's actually going to be doing several more flybys, and eventually will establish a permanent orbit for a 2-year mission. And so by 2028, we should know a lot more about the planet and what exactly is going on with both its surface, underneath its surface, and of course its exosphere. But interestingly, even this recent passage discovered things that we never knew about Mercury already. For example, previous missions detected unusual plasma waves, very often referred to as chorus waves, that usually happen around planets with magnetospheres. And this was expected from a planet with a magnetosphere, but the detection of chorus waves also suggested maybe aurora. These plasma waves very often produce charged particles, which then interact with the atmosphere on planets like planet Earth. Mercury just doesn't have thick enough atmosphere. Its exosphere is extremely thin in comparison to even the Moon. Yet the Bepi-Colombo mission found very intriguing evidence by measuring electrons as it was passing the planet. Here it saw an increase in electrons correlated with a sudden increase in a lot of X-ray emissions visible from the same location, which basically implied that in this case, something is inducing a kind of an X-ray fluorescence, or essentially X-ray aurora, whenever the sun becomes more active. And that by itself is a very strange discovery, because nobody expected Mercury to have these formations, and because it technically should be impossible. Yet it's clearly happening, and it's clearly causing a formation of aurora that we've never seen before. And this is actually something that happens on every planet in the solar system, or so it seems. Basically, this observation confirmed that aurora are a universal phenomenon. They do exist around all 8 planets, but in most cases, maybe for different reasons. We know the aurora on Earth are produced through the interaction of the magnetosphere with the very powerful solar emissions. In this case, this basically causes charged particles to strike the atmosphere from very specific angles, and the charged particles interact with the atmosphere, producing the glow. This is very likely kind of what happens on Mercury as well, but instead of atmospheric interaction, it seems to be an interaction with the surface of Mercury, which results in the X-ray emissions instead of optical light like on planet Earth. In comparison, on planets like Mars, for example, it actually produces ultraviolet emissions, which you can learn more about in a video in the description. On Venus, something similar happens to planet Earth with atmospheric aurora, but on various gas giants like Jupiter and Saturn, because they're much farther away, the effects are much different. On Jupiter, for example, the aurora are permanent and are actually produced by Jupiter's very powerful magnetosphere interacting with the volcanic moon Io. Saturn, Uranus and Neptune have aurora as well, but in that case it seems to be the interaction with the sun again. And so various types of aurora, visible in different types of light, seem to be a completely universal feature that most likely exists in other star systems as well. In this case, no atmosphere required at all, and seems to be the result of the interaction with the surface. And so definitely quite a lot of really exciting discoveries and things we didn't know about coming from the surface of the planet we don't discuss much. But we're definitely going to be talking more about this once Bepi-Colombo assumes a permanent orbit around the planet in 2026, and once it starts studying the planet by focusing directly on its surface and by using various instruments to measure the effects around the planet as well. And so by 2029, we're most likely going to know so much more about Mercury than we currently know now. Hello wonderful person, this is Anton, and today we're going to be discussing some of the more exciting discoveries coming from our neighbor Venus, the closest planet to us. And this is sort of what it looks like if you were to remove the atmosphere from the surface. But because its atmosphere is so thick and so reflective, if you were to just hover above it right now, you would probably see something like this. But in the last few months, we've had some really incredible discoveries about this planet, with the most recent, most exciting discovery being made just a few days ago. And let's actually start with that one first. The discovery, or the official confirmation, that the surface of Venus is definitely volcanically active, with the scientists recently discovering signs of definitive volcanic eruptions that might have happened in the last 30 years. And specifically in the region you see right here, the location known as the Alta Regio. If we were to zoom in, it would sort of look like this. And what's interesting about this particular location is that it contains what's known as tessera. Very unusual formations that seem to represent some kind of a deformed shape, with these unusual strikes in multiple directions, but extremely close to one another. And like other tessera on Venus, this one is also slightly elevated approximately 2 kilometers above the surface. And in this case, it might have been created by some kind of a contractional folding, where the ground starts to fold on itself as a result of some kind of a geological activity. But in this case, very often these also contain a lot of volcanic plains surrounding these unusual features. There are quite a lot of these unusual formations on the surface of Venus, but their origin is still not entirely understood. However, relatively recently, when the scientists were trying to re-examine some of the older images collected by the Magellan probe, specifically around these two massive volcanoes, Oumuamua and Uranus that you see right here, something unusual was discovered by examining the images from February of 91, followed by the images from October of 91. At least one of the volcanic vents, very close to the Uranus, has definitely expanded, with unusual bright features present in the images from October, but absent few months prior. And the best possible explanation here was that this was a result of some kind of a massive volcanic flow. A flow somehow connected to that previously believed to be dormant volcano that might be not so dormant after all. Here's another image showing a little bit more detail. And when in this case it was compared to computer models, the most likely scenario for the formation of this unusual 2.2 square kilometer shape was basically a sudden volcanic eruption. Something that surprisingly or luckily happened around the same time as the Magellan mission. And that of course implies that these volcanoes are very likely a lot more common and very likely are happening right now as well. It is quite unlikely that this only happened during this particular time. And all of these findings were now reported in the paper that you can find in the description below. And this of course is a really important confirmation for what a lot of scientists have been saying for a pretty long time. Venus is volcanically active after all, unlike previous assumptions and unlike previous investigations. And although obviously the surface of Venus is covered in signs of these previous volcanoes from possibly billions or millions of years ago, the confirmation that it even happens now unfortunately creates more mysteries than potential explanations, mostly because it's still kind of unknown how Venus is able to do so and what exactly drives the volcanism on the planet. Although not so long ago, a few weeks ago, some of the scientists proposed a potentially relatively cheap and somewhat intriguing mission that we can actually use to try to explore this and to try to learn more about Venusian geology. It would involve a dozen or maybe even hundreds of different balloons flying around in the upper atmosphere of Venus in order to try to measure tiny variations in air pressure using what's known as infrasound microbarometers. Tiny pressure detectors responsible for measuring variations in pressure produced by these various volcanic eruptions, which could then essentially allow us to see through the atmosphere, or I guess hear through the atmosphere, and thus localize some of these volcanic eruptions in real time. Although at the moment this is still in early planning stages and would not be possible for at least another decade. As a matter of fact, the next planned mission to Venus, the NASA's Veritas mission, has unfortunately been postponed for a few years due to the staffing shortages that I've discussed in one of the videos in the description. And so this mission might start in 2031, and depending on discoveries here, more missions might follow in mid-2030s. And so unfortunately it's unlikely we're going to collect more data about Venus until 2030s. Unless of course there's some kind of an unexpected private mission that decides to launch here faster, but we don't really know what's going to happen just yet. Either way, you can learn more about these Venus balloons in the study in the description below. But I guess let's go back to that previous mystery. So how exactly do those volcanoes work here? What sort of a geological activity is happening here in order to form all of this? Well, despite a relatively similar size and mass between Venus and Earth, these two planets are very different. Earth, as you know, has plate tectonics, geological activity responsible for driving volcanism, and the geological activity responsible for most of the heat loss on Earth. The same does not seem to exist on Venus. But Venus still has to lose some of its heat somehow. And so recent models established that it probably has very different lithosphere and very different crust compared to planet Earth. Its lithosphere is able to conduct heat much easier, very likely because it's structured very differently on the inside, which as a result produces all of these features we don't have on our own planet, but according to the scientists might have existed on Earth 4 to possibly 2.5 billion years ago, before plate tectonics existed on Earth, and when the Earth's lithosphere was also a lot more conductive as well. In other words, in some sense, modern Venus seems to resemble ancient Earth. But one question that was always sort of important is, how much? How much do these two planets resemble? For example, has it ever had any kind of liquid water on its surface? And if so, what exactly happened to it? Well, another recent study discovered a very interesting way to try to answer this question. And the scientists behind this paper were able to answer some of these questions by using various measurements of oxygen in the atmosphere of Venus. And according to their study and their modeling, there is just not enough oxygen in the atmosphere of modern Venus to explain a large ocean in the past. Or to rephrase this, if Venus ever had a large ocean, we would probably still be seeing signs of this water somewhere in the atmosphere. Water is oxygen and hydrogen, and due to various effects from the sun, it would then turn into oxygen and hydrogen, with hydrogen possibly escaping into outer space, but oxygen very likely remaining somewhere in the atmosphere and possibly still detectable today. But modern calculations detected almost no oxygen in the atmosphere. And so to try to explain this, they created something like 94,000 different models, with only some of them matching what we're observing. If there were oceans here, they were very likely extremely small, no deeper than 300 meters or 900 feet. And any oxygen that remained here might have become some kind of a rock on the surface, or possibly turned into carbon dioxide. But unfortunately, this was only seen in about 0.4% of all of the models, meaning that the majority suggested that there might have actually been no water. And even if there was water, it all disappeared more than 3 billion years ago. And in some sense, this implies that, fundamentally, Venus is just a very different terrestrial planet, not Earth-like at all, and possessing its own properties that our planet does not have, with all these unusual properties of Venus then resulting in the extreme atmosphere that it has. And it's this atmosphere that then changed the planet in other ways. One of the major effects this has on the planet is of course its rotation. As you might already know, Venus appears to spin in the opposite direction. And that's mostly because its rotation is just extremely slow, much slower than a single year. All of this is a result of very thick atmosphere. The atmosphere slowed down the planetary spin over time, but exactly how it did so is still not really understood. But the recent observations of Venusian atmosphere kind of take us just a little bit closer to possibly getting it. It involves what the scientists refer to as Venus cloud discontinuity, although more unofficially referred to as the atmospheric tsunami, because it's literally an enormous atmospheric wave, a relatively thick wave, that's something like 70 kilometers in height. And it's essentially a giant atmospheric wave, much larger than anything on planet Earth, that seems to go around Venus, and, as scientists believe, seems to play an important role in helping Venusian atmosphere to accelerate and to move much faster, which then affects the rotation of the planet. And the main reason the scientists are trying to understand what's going on here is because the Venusian winds, unlike winds on Earth, seem to move much faster than the rotation of the planet. In this case, at least 60 times faster, at least in the upper atmosphere of Venus. But why exactly they move so fast was never really truly understood. But this unusual phenomenon known as superrotation, over billions and billions of years, is very likely the reason why Venus stopped spinning as fast, eventually assuming the current rate 243 days per spin. And all of this seems to connect to this unusual discontinuity or this unusual tsunami wave in the atmosphere of the planet. And so by examining the ultraviolet observations from the Japanese Akatsuki mission that took these pictures back in 2022, the scientists were able to see that this discontinuity seems to dramatically change in altitudes and thus change in speed depending on the time of the year, with this unusual tsunami wave only existing at certain altitudes and generally disappearing above 70 kilometers in height. But it's the overall motion of this wave that seems to provide velocity to the winds above it, causing the atmosphere to move much faster than the atmosphere below. Although because this particular phenomenon was only discovered in 2016, it's still very poorly understood even today. Nevertheless, you can learn more about this in a paper in the description below. And last but not least, we have this. A new intriguing project currently analyzed by NASA to create batteries that might be able to operate on Venus for days, weeks, or even months at a time. Batteries that would be able to withstand super high temperatures, super high pressures, and thus, if successful, could also be used here on planet Earth for some of the more extreme environments. And in this case, the current prototype was able to operate for approximately 120 days in conditions extremely similar to what we find on Venusian surface, with the tests conducted at 465 degrees Celsius, generating almost constant voltage for approximately 118 days. Now these are still lithium alloy batteries containing various metal sulfides and a few other components, but the actual internal design allows them to function at very high temperatures. Unfortunately, there was no detail on how exactly this works, probably because of a patent issue, but the tests so far are very promising. And because at the moment there's really almost no other way to generate energy on the surface here, this is actually a really exciting announcement. It means that future Venusian missions finally have a solution to the energy problem. They might be able to operate for at least 118 days. And unfortunately, other techniques of generating energy on Venus would just not work. You cannot use solar power here, it's just a little bit too thick in terms of the atmosphere, and an RTG that uses nuclear power would not work either in these super hot conditions. But on Venus, by using the heat, it becomes possible to turn certain electrolytes that are usually solid and inert in Earth conditions to make them conduct electricity much easier and to turn them into very effective super hot electrolytes. Something that NASA wants to use for their mission known as Long-Lived In Situ Solar System Explorer. Interestingly, the early concepts were trying to use wind power, but that turned out to be not very effective. And so using some kind of a battery-powered mission is most likely going to be the only way. But this mission is not launching anytime soon either. But looks like the major problem has been solved. We now have a way to provide energy. And that was of course the biggest problem before. Pretty much all of the previous missions by the Soviet Union, for example, all failed because things here are just a little bit too hot. The batteries don't last very long, the sensors melt pretty quickly as well, and so the use of more extreme materials or materials that only function in hot conditions is basically mandatory for making this work. Let's discuss new updates from our beautiful neighbor Mars, the red planet that keeps surprising us pretty much every single month. And this time I wanted to start with the discoveries from Martian atmosphere. But really, with this particular picture. The view of Martian horizon captured by the NASA's Odyssey orbiter showing this very beautiful green glow. And though in this case this is just a picture showing us what the Martian atmosphere physically looks like if you were to orbit around the planet, it directly connects to new studies that confirm that Mars does actually glow in different colors depending on the season. And here we're talking about the phenomenon sometimes referred to as the night glow. The atmospheric phenomenon that seems to be present on pretty much all planets in the solar system. But the colors themselves usually differ because of the process that's involved here. Here, during daytime, the light from the sun splits apart various molecules, producing individual atoms. This is known as photodissociation. These atoms then travel across the planet and will usually end up on the night side, where they basically rebuild themselves into various molecules, in the process releasing light. And so here on Earth, quite a variety of different colors are produced in the process. On planets like Jupiter and Saturn, usually this is in much higher frequencies, so it's normally ultraviolet light, but it turns out that on Mars, it produces green colors. And this is due to the breakup of the CO2 molecules, very often in the upper atmosphere, 40 to 150 kilometers in altitude. But intriguingly, a recent study discovered that there is at least one more glow at much lower altitudes, produced by oxygen. And here this was caused by recombination of oxygen atoms created in the atmosphere during summertime, which actually produces visible light. Light that might resemble something like this. And this surprisingly seems to be concentrated in the polar regions of the red planet, mostly because the atmospheric flows seem to converge in the north and in the south. But depending on the season, the overall luminosity seems to change over time. So sometimes it's brighter in the north, sometimes it's brighter in the south. Intriguingly, a very similar type of a glow is known to exist on Venus and is basically produced in exactly the same way. But on Mars, because there is a lot less atmosphere, it actually allows us to study the overall composition of the atmosphere as well. For example, another unusual emission in the ultraviolet suggested that there is also nitric oxide that seems to produce the glowing effects only visible in the UV light. So this is definitely a very intriguing study, allowing us to learn more about Martian atmosphere. Then we have a few more discoveries from the surface of the planet. And here one of them is actually kind of exciting. This literally shows us the ice map, the water ice map of the entire planet. Although mostly focusing on the northern hemisphere, because that's where most of the discoveries have been made so far. But this doesn't show us ice on the surface, it shows us ice hiding underneath, with a lot of the surprises being in regions we didn't expect. actually surprisingly close to the equator. But more excitingly, this is an interactive map, the link for which you can find in a description. So here, if one day you find yourself in need to plan some kind of a mission to Mars and you need a lot of water, use the map. But for me, the most interesting part of this is how this was discovered and confirmed. Because a lot of this was confirmed by looking at various ice-revealing impacts. Basically, various meteorites exposing the surface and then spewing ice all around the crater. And because there are so many collisions on the surface, this allowed the scientists to determine exactly what's underneath. For some of the craters, by looking at how fast the ice evaporated, they were even able to determine what sort of ice this was, suggesting that it's basically 99% pure water. And because some of these locations are relatively close to the warmer equatorial regions, it presents us with a lot more potential landing sites for any kind of a crewed mission. And so there's definitely a lot of water ice hidden underneath the Martian surface. And speaking of impacts, something else was discovered not so long ago by literally listening to the impacts as they happened and then reading the seismic data from the actual vibrations they produced. This was of course done by the now retired InSight mission, and so for approximately 4 years between 2018 and 2022, it observed 18 quakes produced by various impacts that allowed the scientists to try to figure out what's inside the planet. In other words, they were able to analyze the internal structure of the planet, revealing its layers. And although the initial discoveries suggested that the core of Mars might be a little bit bigger, the recalculations, based on several quakes produced by these meteorites, determined that the core here is approximately 1650 kilometers in radius, but seems to have a somewhat unusual layer of molten rock right above it. A kind of a second liquid layer. And so basically there are two liquid layers inside Mars, the liquid core and the molten rock right above it, which actually would suggest that Mars can still be somewhat geologically active sometimes. And as the scientists were wondering how often, and basically can it actually produce some kind of an earthquake or a new volcano, they got their answer almost right away. Within the same time frame, there was actually a detection of the largest quake ever, something that lasted for about 6 hours, and something that did not resemble a typical meteorite strike. And since all of the other detections also left behind a crater that was discovered later, sometimes even a large crater, in this case, nothing was actually found. This mysterious earthquake did not have an origin from the surface, and since the magnitude for this earthquake was 4.7 on the Richter scale, this suggested the size of the crater to be approximately 300 meters across. Something like this would have been seen almost right away. And so instead, the conclusion here was that Mars is indeed still geologically active, produces earthquakes, but exactly how is currently unknown. It's most likely not in the same way that we have earthquakes on Earth. There are no plate tectonics here, there are no continents, but it could be related to some kind of a stress inside the planet, or something else we don't really understand yet. But this is of course an important discovery, once again for those crewed missions. If we go to Mars, we have to be aware that not only are there meteorite impacts, there are also earthquakes, and dust storms, and no air, also radiation, and most importantly, no fast food or Starbucks coffee. So yeah, I'm definitely not going. But there were some other discoveries from the surface and from just underneath the surface from another mission, specifically the Zhurong mission by China. And here this was the result of ground-penetrating radar discovering something at a depth of about 35 meters underneath. It discovered unusual polygonal structures, anywhere from a few centimeters to a few meters across. And here they seem to resemble something we usually see on Earth as well. They resemble this. This is a result of thermal contraction that basically ends up cracking the surface, but then these cracks are then filled with water, or possibly ice that's hiding underneath. But because this is seen as sediment and is actually inside the ground, this must have happened a long time ago, possibly billions of years ago, and was very likely buried by some kind of a major cataclysm that happened in this region on Mars, producing this huge amount of sediment on the surface. And so even though this is a sign of water-ice cycle once again, here this also shows us a dramatic change in climate, or potentially some kind of a cataclysm that had a huge impact on a lot of soil in the location at low to mid latitudes. So even though Mars used to have water, something major must have happened afterwards in order to change the surface so much and cover it with so much sediment. What exactly happened we obviously don't know, but it's definitely an intriguing new mystery. And lastly, we have this relatively cool video produced by ESA. A video of the region known as Noctis Labyrinthus, a huge formation on Mars that basically looks like a bunch of valleys and is located between a really large canyon known as the Grand Canyon or Valles Marineris and the tallest volcano in the solar system, Olympus Mons. But in this case, Noctis Labyrinthus is actually a really intriguing system that stretches for approximately 1200 kilometers, I guess around 800 miles. And what you're seeing here is a simulation or a visualization of what Mars Express would physically see with its camera and the pictures that it usually produces as a result. And a lot of these canyons have a name. They're known as graben. It's basically crust that suddenly fell into the ground compared to the surroundings that remain on the same level. But because of the size of this, the question is, what exactly produced this? With the answer being the extreme activity, geological activity on Mars. Here's actually what this region looks like if you were to look at it from farther away. And it's basically a result of the activity from this enormous volcano you see right there and from its partners nearby. As a lot of this volcanism started, it was so intense that it actually caused huge areas of Martian crust to start arching upwards and become stretched in the process. And this enormous stress on the Martian surface started to produce a lot of faulting along this entire region, with large chunks of the surface falling underneath and forming various canyons and valleys, some as wide as 30 kilometers in width. And so basically pretty much all of this is a result of extreme Martian volcanism, so powerful and so dramatic that it kind of reshaped the surface of Mars, making it twist and stretch in a certain direction. Hello wonderful person, this is Anton, and it looks like we have some new updates about Jupiter and about its moons. Actually, it's mostly about the moons, not so much about Jupiter. With these updates mostly focusing on new images, but also potentially explaining a very important mystery of how magnetosphere seems to operate around Ganymede. And that by itself is already a really important discovery. And so let's discuss these updates in more detail, and let's start with the object behind me, Io. Right before the end of 2023, NASA's Juno probe conducted the closest ever flyby of Io, taking the highest resolution pictures ever. This is one of them, revealing Io in a way we've never really seen it before. Gorgeous colors, unusual patterns, and all of this a result of super active volcanoes on its surface. As you might already know, this is the most volcanic moon in the entire solar system, with over 150 active volcanoes on the surface and 400 in total. And though a lot of previous images sort of make it look like this, these new super accurate images present us with a lot of detail we've never seen before. As a matter of fact, this image right here was probably the most surprising. This was actually a highly enhanced image, but as you can see right there, it shows us volcanic vapors escaping from inside the moon. And since the moon is about 3600 kilometers across, these are enormous emissions, basically over 100 kilometers in height. So this by itself is already really impressive. But what's even more impressive is the recent discovery by an amateur astronomer, Jasper Sandberg, who analyzed one of the older pictures of Io and discovered something nobody has ever seen before. He was actually looking at the picture taken by Galileo probe back in 2001 and completely by accident discovered something very close to this very unusual canyon you see right here. He basically discovered a previously unknown small impact crater approximately 100 meters across, and it seems to have ejecta around it, and so this could be a relatively recent impact. Now, because this is a volcanic moon, most of the surface here usually gets reshuffled very quickly, so you don't really get to see a lot of impact craters as a result. And so discovering at least one is sort of exciting. But a much more exciting discovery is actually a result of an experiment that tried to understand and explain the magnetosphere of Ganymede. Ganymede, that's only a little bit larger than our own moon, contains a surprisingly powerful magnetosphere for an object of its size. It even contains aurora that we discussed in one of the previous videos. But it's not the same as the Earth magnetosphere, and it's a lot more hectic, a lot more distorted, and contains a lot of features we still don't understand. And more importantly, up until recently, it wasn't actually clear how exactly it's generated. Because of its unusual shape, it seems to be a result of something a little bit different from what happens inside planet Earth. And we know that for our own planet, it's most likely the result of extremely active dynamo or motion of liquid metal inside the outer core that sort of churns around and produces various magnetic loops that combine together to create a much larger field. But what exactly happens here? Well, first of all, we know that all of these moons experience a huge amount of squeezing and stretching from Jupiter and their partners. So they definitely contain a lot of heat on the inside. But what exactly this does to the internal structure of the moon is of course unclear. But the researchers behind the study you can find in a description had a very intriguing proposition that they decided to prove by using an experiment with water. They essentially believe that it's a result of a phenomenon known as crystallization of iron snow. Or for the lack of better words, it seems to snow iron inside the moon, with the motion itself then generating unusual patterns that create magnetic fields or magnetic loops. And their experiment seems to prove this really well. So here's what they actually did. Here they took a tank of water that was being cooled from below and added a layer of salty water or brine water that rested on the bottom, with a layer of normal non-salty water on top. And this sort of imitated two different densities and two different properties that we usually find inside various moons as well. But in this case, water sort of mimicked iron. But because of the heat interaction and because of the cooling and warming, they started to observe a lot of motion going up and down. But unlike a typical lava lamp, they started to observe the formation of tiny snowflakes that started moving away from the salty liquid upwards. And so in their experiment, they observed a kind of an unusual motion of upward snow that moved across different layers of water. This was a result of formation of ice crystals inside the tank, which basically formed right at the level between the salty and fresh water. And this could then be interpreted in a similar way inside the moon, except that it was basically upside down. Here it was very likely that the snow was moving downwards toward the core, floating backwards again once it's melted. And so what the scientists suggest here is that some kind of an unusual motion, circular motion, is generated by these snowflakes as a lot of liquid iron crystallizes inside the moon and starts to form this motion all across the surface. And this dynamo then generates magnetic fields. But one of the surprising findings here was that it does not seem to be constant and doesn't seem to have the same rate at all times. As a matter of fact, it seems to accumulate until a certain trigger point, and then all happens pretty much at once, with a lot of periods of inactivity in between. And this is a super important discovery because it can potentially explain why we seem to observe very sporadic activity around Ganymede as well, and why the magnetosphere seems to have an unusual shape compared to planet Earth. More importantly, it sort of implies that the magnetic field is localized at different regions depending on the time. Sometimes the snowfall might occur in one location, other times it's going to occur in a different location, resulting in a major shift of the magnetic field over time. But I guess more importantly, this also very likely applies to a lot of other moons and even Mercury. Many smaller objects very likely contain similar properties inside, and objects like Mercury also contains an unusual magnetosphere as well. And so this particular experiment potentially presents us with a very good explanation. And for all we know, this is maybe also something that used to happen on Mars and might even still happen on Mars to some extent. And technically anything that contains a large enough metal core. So yeah, a super interesting discovery and a super interesting experiment. And combined with previous discoveries about Ganymede from last year that you can learn more about in the description below, all of this completely transforms our understanding of Ganymede and what seems to happen on its surface and also inside of it. Then once again we had a few observations from Europa, and here it was finally confirmed that there is carbon dioxide on the surface, with the James Webb Space Telescope confirming that the source is underground oceans. And this was actually proven because most of it seems to be located in Terra Regio, a location with a lot of chaotic terrain that contains a lot of emissions from underneath. And that mixed with the discovery of various salts in this location sort of points at super intriguing chemistry going on inside the moon. And it would actually be very difficult to explain CO2 and all of these salts without the presence of something really intriguing inside, and potentially life. We know a lot of these minerals and salts, along with CO2, is what a lot of bacteria on Earth also produce. This is usually a type of a biosignature here. And so at the moment this is a really intriguing sign that there might be life on Europa, or technically inside Europa, after all. But all of it hidden inside the ocean underneath. And though this is not 100% certain, and the CO2 here could have actually come from maybe some kind of a chemical reaction we don't understand, luckily this year we also are getting a new mission, Europa Kuiper. A mission whose goal is to find out what's leaking from within Europa, and if any of these elements are truly signs of life or maybe something else. This mission is going to be launched in October of 2024, but it will take a few years before we get first results. And then last but not least, we also get new images of Jupiter itself, this time taken by the Hubble Space Telescope and taken in the UV, showing us Jupiter in ultraviolet light. And it definitely looks very different. Here, whatever is darker basically absorbs UV light, and as you can see, the great red spot seems to absorb the most. And this is actually caused by a lot of different hazes and a lot of different aerosols that seem to be generally associated with extremely large storms inside gas giants. You can also see that there are some of these aerosols in a few of Jupiter's stripes, but also quite a lot of them in the polar regions. And though by itself this image is obviously kind of interesting, the main reason this was taken is to try to map water clouds inside Jupiter's atmosphere. This is actually going to allow scientists to create a kind of a three-dimensional picture of water clouds on the planet. And here's what this image would look like if you were to combine it with normal optical light. Actually, this is also mixed with the infrared light, the image from the James Webb. And so if somehow our eyes could see infrared, UV light, and of course optical light, this is what Jupiter would possibly look like. Absolutely gorgeous. Definitely incomparable to the regular image of the optical light. But once again we're missing one object, Callisto. Still nothing from Callisto. Why not? It's been like a year now and we haven't heard anything, no pictures, no discoveries, pretty much nothing. Yeah, I'm not sure exactly why Callisto has been ignored for so long now, but hopefully, maybe sometimes in the next few months, we'll hear a little bit more about this fourth Galilean moon, discovering more about it, and potentially solving its mysteries as well. So looks like James Webb Space Telescope finally achieved it. We finally have images from all 4 giant planets in the solar system, with all of the data now collected and ready to be analyzed. Hello wonderful person, this is Anton, and so today let's start with what was just released by the team processing all of the data from the James Webb. Well, it actually started with this, an intriguing picture of Saturn, but in this case, an image that was still not processed, an image that is still kind of difficult to understand. This is essentially the raw data that you can technically even download yourself, because all of this is publicly available. But it didn't take very long before the first images that were processed started to appear as well, with this one I think being the best so far. And this is Saturn, visible in the infrared frequencies, with other images focusing on other details, revealing more things that were invisible previously. Which of course means that we now have all 4 planets imaged in the infrared and investigated by the James Webb. It took just over a year to get all of this, but it's probably going to take a few months before all of the studies that were focusing on all of this data are going to start coming out with all of the new findings from all of this huge amounts of data. And so at least for now, we get these beautiful images showing us these 4 planets like we've never seen them before. Intriguingly though, as you can see, Saturn, Neptune and Uranus seem to contain easily visible rings. Jupiter though does not. And that's because the rings here are a little bit more difficult to see, predominantly because they're made out of slightly different material. Although if you want to learn more about this and you want to learn more about Jupiter, Neptune and Uranus and all of the discoveries made so far, check out all of the previous videos in the description below. Nevertheless, from all of these 4 images, we definitely get to see these planets in a way we've never seen them before. For example, for Jupiter, we seem to observe these permanent aurora that are generally invisible in optical wavelengths, but are definitely visible in higher frequencies or in the infrared, with the rings also generally invisible in the optical light, but once again visible with infrared frequencies. When it comes to Neptune, which is the farthest of these planets, this is probably the most detailed image we have ever since the Voyager 2 flyby in 1989. And here I think it's the rings that are probably the most exciting, as well as tiny moons visible inside the rings as well. Here's the annotated version of this, and as you can see, one of the brightest objects is the large moon Triton, the moon that's potentially extremely similar to objects like Pluto. But we also get to see other 6 moons, with 7 other moons invisible in these images. But the other intriguing part is of course these unusual bright spots in the atmosphere. These are very likely active storms, and seems to suggest an active global atmospheric circulation present on this planet. This can be barely seen with optical light or with telescopes like Hubble, and some of the previous discoveries from Hubble have actually created more mysteries than answers. Here though, we might be able to get some closure once the scientists figure out how this atmosphere works. And then of course we got these strange images from Uranus, the planet that's, as you can see, completely on its side. But once again here, it's the rings that seem to take precedence. they seem to be very well ordered and create these very beautiful, unusual patterns. And as we've recently learned from studies on Saturn, rings in general can be used to study the atmosphere of the planet and to even discover unusual anomalies inside the atmosphere by looking at various variations and patterns formed inside the rings. I'm sure the studies about this are going to come out, possibly in the near future. And so this beautiful image reveals 11 out of 13 different structures present inside this beautiful ring system. But once again, an unusual brightening that seems to be very close to the polar cap. And though it's kind of similar to what we saw on Neptune, here it's much bigger and its origins are currently unknown. But the most intriguing thing about both Uranus and Neptune is that despite similarities, in infrared light they do seem to have very different colors. Here's by the way the zoomed out version showing us some of the moons as well. And so it's the coloration here that seems to be a bit of a mystery. Generally the scientists believe they do contain similar materials, but the properties in their atmospheres seem to be different enough to produce different visual effects. What's exactly happening here is of course not something anyone can answer right now. And now we have our fourth addition, Saturn. And this one I think is probably the most unusual and the most unexpected. Here's of course what Saturn looked like before, with images taken by the Hubble telescope in optical light. And one prominent feature that's definitely visible in the optical light are these unusual stripes visible on the surface. But these features disappear in the infrared light. And because infrared temperatures generally show us heat or thermal properties, it sort of suggests that the temperature here is more or less the same, with what seems to be polar regions that are once again slightly different in color. I actually thought that this image from practically 20 years ago presents us with a very interesting contrast. Here you can see the visible light, the ultraviolet observations, but also some of the first observations in the infrared. This was by the Hubble telescope as well. And here, the stripes were still kind of visible, but this was in different frequencies. Because James Webb is able to see much deeper in the infrared light, and because it's not showing us any optical observations, all of these unusual stripes completely disappear because of methane-rich upper atmosphere that pretty much blocks all of the clouds underneath, and thus obviously blocks the heat as well. But we do see some kind of an unusual dark shape visible in the northern hemisphere that's possibly created by some kind of aerosols present way above methane clouds. But it's still kind of surprising how different it looks from Jupiter. First of all, no aurora visible whatsoever, and second of all, no unusual storm-like features, or really any features, that we do see in optical light, but that are pretty much absent here. But unlike the atmosphere, the rings are definitely very easily visible, along with several moons. And it's really intriguing how it's the rings that seem to be the brightest objects in this entire image. Much brighter than the planet itself. And so in this annotated image, you can definitely tell apart the dark C ring, the very bright B ring, the Cassini division, the somewhat bright A ring, and the unusual Anki gap that ends with the F ring at the end. But because this is just the first image, we still don't get to see the other rings that should be visible on the outskirts as well. As a matter of fact, the G ring that should be visible seems to be absent, as well as the large diffuse E ring that is believed to be produced entirely by the moon Enceladus that you see right there. And that's of course the other major discovery coming from the system in the last few months. A major discovery coming from Enceladus itself. The strange, mysterious, and very exciting moon that you see right there. Once again, the center of the E ring. This by itself is clear evidence that it's creating the entire structure. And so as we've known for many years now, Enceladus has these very large emissions that, as we've recently discussed, don't seem to be geysers or even volcanoes, but instead seem to be a result of very violent sudden evaporation as the liquid water from within is exposed to outer space. And this of course ends up extracting a lot of materials from within the internal ocean and releases it into the rest of the Saturn system. And intriguingly, unlike other objects in the solar system that have a lot of water and extremely large oceans within them, Enceladus doesn't actually have that much, at least by mass, but it seems to be approximately 14% liquid water, making this one of the most water-enriched moons, or really any objects, in the entire solar system. But it still very likely contains a really large rocky body inside of it, which is probably made out of some kind of a carbonaceous chondritic rock, potentially similar to various asteroids that orbit everywhere in the solar system. And because of the tidal interactions with Saturn and with the other moons, there's basically a lot of mixing and a lot of sloshing of this relatively small ocean with lots of different organic molecules present inside this unusual core. with many of these molecules then making it to the surface and eventually being expelled through these unusual jets produced by the moon. And extremely recently, the scientists identified something nobody expected: phosphates. The same stuff that our DNA and RNA are made from, and also the same stuff that our whole body uses for energy. And of all possible molecular discoveries, so far this is actually one of the most exciting ones. Mostly because finding phosphates in an ocean on an alien world dramatically increases the chance that we might discover some kind of a strange, unusual life. But more importantly, organic life. Life similar to planet Earth. And more importantly, the chance of this happening on Enceladus has now increased dramatically because all 6 important elements of life, carbon, hydrogen, nitrogen, oxygen, and sulfur, have also been discovered here as well. This moon seems to contain everything you would need to create primitive life. And with the discovery of sodium phosphates, it's basically now all about just going there and trying to see if there's anything present in those oceans underneath the ice caps. Although the only way we could probably ever come here is by using some kind of an advanced rover that can dig through all of this ice and then explore the ocean. Intriguingly, NASA and JPL is currently testing such rover right here in California mountains. And this is really cool because it's basically some kind of a snake-like object that's able to move on the surface but also able to dig deep into the ground. You can learn a little bit more about this in one of the videos in the description, but in essence this is maybe the future of Enceladus mission. A somewhat strange, unusual, but somewhat effective snake-like object that's able to explore the oceans underneath. And because it's already been tested successfully here on Earth, it's now just a matter of time before all of this can be planned officially and launched sometime in the future in order to explore this unusual moon. I think this image right here represents this really well. If successful, this would be the most exciting mission ever and potentially make incredible discoveries underneath. But all of this was really made because of these observations inside the E-ring made with the James Webb Space Telescope. And so now we have really good reasons to try to go there and to potentially finally have an answer for, is there life out there outside of planet Earth? Because at the moment, Enceladus is definitely that one location that seems to show the most signs. But if the life here doesn't exist, and also if the other exciting moon, Titan, reveals no signs of life either, well, that's when we have to start asking bigger question. Is life just very unique and extremely rare? But these are of course just first observations of this beautiful system, and the first images coming out of James Webb. Here, the Northern Hemisphere is actually currently reaching the end of its 7-year-long summer, and so the images will probably change in color and look very different in the next few years. Which by the way might help us answer what's actually happening right here in the northern region. So yeah, today we're going to be talking about Uranus. Leave your jokes in the comments below. Okay, yeah, technically I've always been pronouncing it as Uranus, and that's the more proper way of saying it. And essentially what we're going to be discussing are some of the new discoveries, and some of the more unusual discoveries, from the mysterious 7th planet. The planet that we actually know very little about, and the planet whose moons are even more mysterious, for reasons we're going to discuss today. But because of the unique position Uranus currently has across the solar system, it presents the scientists with a unique opportunity to study exactly what happens inside this planet, which led to several major discoveries in just the last few months. Hello wonderful person, this is Anton, and today we're going to discuss some of the recent discoveries coming from various telescopes, including the James Webb Space Telescope, in regards to Uranus and its 27 moons. Although we're mostly going to focus on 5 moons, and some of the more unusual discoveries that sort of surprise the scientists. And I think here it's important to start with some of the most recent observations from the James Webb Space Telescope. The observations that only lasted for approximately 12 minutes, and in those incredible 12 minutes, this is what it was able to see. An incredibly beautiful composition of Uranus and its major moons. But what's really intriguing in this image is of course how extremely bright the rings appear in this image compared to anything else we've ever seen. On top of several bright features that are now visible inside the atmosphere as well. Just to give you a comparison, here is the only image we previously had of this planet from the Voyager probe, which basically make it look completely plain and somewhat boring. Although even here, if you look at the planet in different light, for example infrared light, you're able to see something else happening along the polar regions. But prior to this, a lot of previous observations basically gave us this. Not a lot to work with here, but the planet barely being visible. The previous Hubble images are a little bit better, but they still do not provide a lot of detail and mostly show us the surface in optical light.
But the February 2023 observation from the James Webb Space Telescope suddenly reveals a planet with a somewhat dynamic atmosphere, specifically an unusual brightening at the center of the polar cap. And that's because Uranus, like planet Earth, has its own seasons. But the seasons here usually last for a very long time, 42 years of sunlight followed by 42 years of darkness, because the planet also spins on its side. And so here, as the northern hemisphere becomes exposed to the sunlight, the polar regions along the hemispheres also change color. And this polar cap that's unique to Uranus will most likely vanish in the next couple of decades. But what's intriguing in this image is of course that you can also see individual clouds, only visible in infrared wavelengths. And in this case, the scientists are almost certain that this is related to extremely powerful storm activity that's obviously also visible on other planets as well. But unlike Earth, where this is all water vapor, on Uranus it's water, methane, and ammonia. And we obviously also see 11 out of 13 known rings, with a lot of them appearing brighter than anything else before. And there is something really intriguing discovered about the rings very recently that we're going to discuss in a couple of minutes. But just by itself, this image is already quite incredible. But more recently, the scientists used a microwave telescope, specifically the Very Large Array from New Mexico, to try to look into this polar region and discover what's inside the storm, confirming that this is actually a very powerful event as visible in these images. Here you can see it in 3 different frequencies of microwave wavelengths, and what this essentially proves is the fact that pretty much 7 out of 8 planets in the solar system all contain storms. And not just any storms, very powerful cyclones and anticyclones, with overall similar physics, but usually extremely different in size and more importantly, different in composition. Here's what we have on Earth, here's something we have on Mars, and in this case this is mostly dust. Jupiter obviously has a bunch, including the famous Great Red Spot, and something similar has also been found on Neptune and Saturn as well, with Venus having its own versions of polar vortices as well. The only planet that we haven't found anything on just yet is Mercury, probably because it has no atmosphere, but for all we know, it has its own version of these cyclones that we just haven't found yet. But unlike Earth, where all of this is formed over water and relies on very specific heat exchange, a lot of these other vortices around other planets seem to essentially form over a fixed location and potentially represent extremely massive 3-dimensional structures. We basically only see the surface, with these discoveries also implying that this seems to be slightly warmer and drier air, which is what we expect a cyclone to have. And so even though we call these planets ice giants, the reality is that they are extremely active and possess a lot of internal activity that we just cannot observe very easily. But a lot of discoveries in the last few months were also in regards to the moons and the rings, or technically the connection of the rings to the moons, with the first major discovery coming in regards to the 5 main moons of Uranus: Ariel, Umbriel, Titania, Oberon, and Miranda. You can see that there are 4 very large moons, and Miranda is a bit on the smaller side. Now, a lot of this was mostly based on modeling and trying to figure out exactly what's on the surface and inside these moons, but overall the scientists discovered that these moons seem to be quite insulated, with a relatively thick surface that in theory should allow them to sustain liquid oceans inside. And although maybe not as big and as profound as oceans on objects like Europa that you see right here, the moon of Jupiter, it's quite likely that these moons would contain heat sources on the inside to maintain warm environments, as well as even materials like ammonia, which can act as antifreeze, with recent evidence that you can find right here even suggesting some kind of a flow that happened relatively recently on the moon Ariel, possibly from some kind of a subsurface ice volcano. And the study suggests that some of these oceans might even be warm enough to sustain habitability for potential primitive life. In other words, we have another planetary system in the solar system that contains moons with oceans inside, and even a chance for some kind of a subsurface life. Which is of course an excellent opportunity for someone to finally start planning a mission to this unusual faraway planet. Except for the Voyager 2 probe, nobody has ever visited Uranus or Neptune, and the potential mission here has been actually in planning for decades now. Nothing so far has happened. But then we have some really intriguing discoveries from the strangest moon in the solar system, Miranda, the smallest of the big moons around Uranus. And just looking at the picture of this moon can kind of explain why we call it the strangest moon, or sometimes the ugliest moon, because it has these unusual, very difficult to explain features which it really shouldn't have. Its surface is covered in a lot of very unusual stuff. And it's also home to the largest 20-kilometer high cliff known as Verona Rupes. Apparently if you jump from this, it would take you nearly 15 minutes to reach the bottom. And so overall Miranda has one of the most extreme surfaces in the solar system, containing a lot of unusual scratches, a lot of unusual chasms, weird valleys, and a lot of features that are just very difficult to explain. It's also about half ice, half silicate rock, so even its composition is a little bit strange. And because this moon is so small and overall is believed to be relatively cold on the inside, it's impossible to explain any of this using some kind of a geologic activity such as volcanoes or things like plate tectonics. And so the question has always been, what happened here? Why is it like this? It should not have enough heat and enough energy on the inside to produce any of these geological features. And well, there's always been three main explanations. Some kind of an impact, some kind of a volcanic or plume deposit similar to the ones we observe on Io, or maybe this was from the rings of Uranus. And so one of the recent studies wanted to investigate exactly how possibly all of this formed, specifically looking at the relatively thick layer of regolith and a number of different craters located on the surface that can actually help the scientists determine how thick the surface is. And what the scientists realized in this case is that, well, it seems that due to the location around Neptune, and due to the composition on the surface compared to the rings around Saturn, there's actually a very high correlation between the two. Or basically, a lot of this might have come from ancient Uranus rings that over time deposited all of the material on the surface as this moon, sometimes back in the past, moved across the rings or very close to them, capturing the material in the process. Which of course implies several things. First of all, that this moon was much smaller and very likely contained different materials in the past, but second of all, the rings around Uranus must have been massive before. Massive enough to enlarge the moon and create all of these unusual features. And because both Miranda and the rings also seem to possess slightly similar blue color, on top of a lot of other features, at the moment the scientists believe that this is maybe the best possible explanation. This moon basically sucked up a lot of ring material, in the process forming these unusual features we see on the surface, which by itself already warrants a potential mission to this moon, as it's going to help us learn so much about Uranus and the entire solar system, with I guess the obvious, more intriguing question in this case, being Saturn. Can something like this also happen around Saturn in the future? Will one of the moons absorb some of the rings and possess these features kind of similar to Miranda?
We now have some really exciting discoveries coming from our mysterious neighbor, Neptune, or I guess far neighbor, the farthest planet in the solar system. And in this case, these are some of the more unexpected discoveries nobody can currently explain. And let me try to show you why. Here's the simulation of Neptune from Space Engine, where you can clearly see clouds on the surface. But now we have these very unusual observations that imply most of the clouds seem to have completely vanished. And though some of the older images from early 2000s contained a huge amount of clouds, the recent observations from the James Webb reveal almost nothing. And that's pretty much the opposite of what scientists expected to find. So, hello wonderful person, this is Anton. Let's discuss some of these recent discoveries about Neptune and its unusual atmosphere, mostly focusing on these two recent discoveries from two separate papers. But first, I guess, a bit of a clarification. Obviously, because it's very distant from the Sun, a single year here is approximately 165 Earth years. And basically, a single season is approximately 40 years. So all of these changes are expected to be somewhat seasonal. Right now, Neptune is believed to be right in the middle of its summer. But instead of warming up, it seems to be actually doing the opposite. It seems to be getting colder. This was previously discovered by using infrared observations from a lot of different telescopes. And all of this is probably a result of very specific gases in the upper atmosphere of Neptune. Here we have methane, which usually absorbs sunlight and warms up the atmosphere, but also various types of hydrocarbons, such as ethane and acetylene, which usually reflect infrared light, cooling down everything. And so usually the balance between these gases produces various temperature fluctuations. And it's always been assumed that these changes are going to be kind of gradual. But between 2018 and 2020, the changes were quite extreme and quite sudden, producing unusual observations and unusual seasonal effects. And the first explanation here
actually involved our Sun. A lot of these observations seem to be correlated with solar activity. Now, correlation is not causation, but it was still a pretty intriguing discovery. We'll come back to why this is important in a few minutes. Likewise, a few years ago, there was a sudden appearance and then disappearance of a strange dark patch on the surface. Two actually. These were very likely storms, but why they disappeared so suddenly and why they appeared so suddenly was not clear. But once again, potentially related to the solar minimum that happened around this time. And even though Neptune is 30 times as far away from the Sun as planet Earth, more and more evidence seems to suggest some of the fluctuations here follow the typical 11-year cycle that happens on the Sun. Our Sun goes through maximum activity every 11 years, although actually a lot more recent evidence suggests that the cycle might be 22 years, and so every 22 years, the cycle is much stronger than before. Anyway, things here get a little bit more complicated, but the video in the description explains this better. The point is that it looks like the Sun influences some of the more complex molecules in the atmosphere of Neptune, transforming the upper atmosphere and thus affecting some of the features on the surface. But these recent pictures showing us no clouds take this to a completely new level. For example, here's a graph showing us solar cycles, or total solar UV radiation, and the amount of clouds on the surface. And based on the video in the description and the study related to this, the assumption is that this solar cycle is one of the strongest in the last few decades. The Sun is going to be extremely active for at least a few more years, and it's going to reach the peak of its activity in 2025. And because the Sun was already active in 2020, it may potentially explain why many clouds suddenly disappeared, making Neptune look very different. But I guess the obvious question is, why? How does any of this work? Well, we can only speculate, but the assumption here is based on what we know about methane on planet Earth. Methane is not a stable greenhouse gas. It usually survives in the atmosphere for approximately 12 years, but it's also actively destroyed by solar radiation. And so in this case, by receiving more UV light during certain periods, it's possible that it maybe destroys more methane, thus cooling Neptune down. And because a lot of these clouds seem to be made out of methane as well, there is a possibility that maybe this destroys the clouds as well. Although honestly, this is just a really big assumption. There is no actual answer just yet. Just visual observations and certain correlations with solar activity. Nevertheless, after almost 4 years now, there are still very few clouds. And we know that the Sun is very active. So something really complex must be going on here, affecting all of these observations. Nevertheless, even after almost 4 years now, there are basically no clouds, with many of these unusual processes still not truly understood, and most likely being a combination of many different factors. With the conclusion being that the solar radiation, specifically ultraviolet radiation, when strong enough, can trigger various photochemical reactions that can affect the clouds on the surface. Now, it's quite possible that it destroys the clouds, but it's also quite possible that it actually forms them. So yeah, it's not clear exactly what's happening. For example, in this graph, the correlation is that high UV radiation means more clouds. But based on the studies from planet Earth, we know that UV radiation destroys methane. So it's probably really early to come to any conclusions. Likewise, this recent study identified that the highest albedo or reflectivity of the planet was back in 2002, but then it dropped dramatically in 2007. In this case, high albedo means lower temperature. But between 2007 and 2015, it started climbing again, changing the temperatures even more. Moreover, it's kind of intriguing that none of this seems to happen on Uranus, which is much closer and which also contains relatively similar components. But when it comes to the storms, they probably come from within Neptune and are most likely not related to photochemical reactions. And so, in the end, we have this really complex interaction of various factors that basically seem to go against predictions made previously. The planet is cooling down and not warming up, it's losing its clouds, and it even lost all of its storms. None of this was predicted years ago. Luckily, new observations from the James Webb, along with the fact that the Sun is going to become the strongest in 2025, might allow us to finally come to certain conclusions in the next couple of years. But because one cycle here is 160 years long, and we only have like 20 years of observations, most of this at this point is a bit of a guesswork. We just don't have enough data from other cycles. But I guess to make things even more complicated, a recent independent observation that you can find in the description below, with a study by Patrick Irwin, discovered another really interesting feature on Neptune by scanning it through different frequencies of light. This was done using what's known as MUSE or Multi-Unit Spectroscopic Explorer, part of the Very Large Telescope. And so by splitting the image into various wavelengths, they were able to spot an unusual formation detecting a strange dark spot that's never been seen before, which maybe represents a clearing inside the clouds, or maybe something else entirely. At the same time, they also discovered unusual bright spots extremely close to that dark spot that could be new types of clouds we've never seen before on Neptune or Uranus. Because it seems to be on the same level in terms of depth, there is probably some kind of a relationship between these unusual features. And so whatever this is, it seems to be a new type of a phenomenon inside Neptunian atmosphere. But I guess more impressively, just the fact that they were able to scan this in 3 dimensions by using specific wavelengths. It essentially allowed them to create 3-dimensional representation of the entire atmosphere of Neptune, more or less represented in these 4 separate pictures. At the moment, the assumption is that this dark spot is probably formed by reduction of atmosphere by about 5 bar and probably is made out of condensation of hydrogen sulfides. But the strange dark spot is surrounded by these strange white spots that don't seem to exist for a very long time. But more importantly, this feature definitely seems to be very different from the previous dark spots that were discovered in a completely different layer of Neptunian atmosphere, which once again reminds us that Neptune, unlike planet Earth, has a variety of different layers interacting with one another, with layers deeper and deeper within, containing their own mysteries, their own features, and their own strange formations that then might influence the layers above them. Which also means that maybe these clouds and a lot of these formations we're missing now are also a result of some of the activity underneath and not really the sun after all. So yeah, it's a mystery, nobody has any answers just yet, and someone should probably launch a mission to Neptune sometimes in the future. One of the Voyager probes was the only time we visited this beautiful planet, and nobody has ever gone back since. But we really should. So much stuff to discover here, and so many things to learn about when it comes to exotic atmospheres, strange planets, and of course, their moons. But for now, that's pretty much everything I wanted to mention. Check out previous discoveries about Neptune in the description below, subscribe, share this with someone who loves learning about space and sciences, come back tomorrow to learn something else, support this channel on Patreon by joining channel membership, or by buying the wonderful person t-shirt you can find in the description. Stay wonderful, I'll see you tomorrow, and as always, bye bye.